Yes, sir.
Okay.
Okay, shall we start?
Start.
Okay. Good afternoon. Welcome to all the delegates and invitees who have joined this webinar from India as well as various parts of the world. A big thank you to all our eminent guest speakers who have kindly agreed to spare time for this virtual conference and share their knowledge and information about the fast emerging industry of plastic packaging waste management and sustainable technology solutions. On behalf of the Foundation of Innovative Technology and Sustainability, FIPS, we also take the opportunity to the Mahatma Gandhi University of Kottayam. Thanks are also due for the support of this seminar, of this webinar by our sponsors, Karure Eval, Deluxe Recycling and Nature Preserve, as well as our media partner, Polymer Communique. This webinar by FIPS is part 2 of a series of webinars planned by the Foundation to discuss issues around achieving packaging, sustainability, and circular economy. Part 3 of this webinar series will address issues regarding governance, challenges, and opportunities regarding packaging waste management. It is scheduled tentatively for February 2022, and the date will be informed as soon as confirmed. The theme of today's presentation is, in the technical sessions, is deriving value from post-consumer multi-layer packaging waste. The objective is to highlight and understand how wealth can be cost-effectively derived from post-consumer use MLP waste. As I'm sure most of us present here would know, amidst all the pious talk of sustainability and circular economy, the collection, segregation, processing, and recycling of post-consumer use multi-layer flexible packaging pouches, MLP, has remained a formidable challenge. However, the good news is that this last frontier for recycling technology has begun to be conquered by some pioneering efforts by Nestle, Uflex, Karure, Eval, Nature Preserve, and Deluxe Recycling. So let us sit back and learn from the eminent guest speakers here how used flexible packaging laminate waste can now be profitably recycled. To start our proceedings today, I would like to invite Professor N.C. Saha, Dr. N.C. Saha, Founder Chairman FIPS, to make a welcome address.
Thank you, Deepakji. Very good afternoon, Professor Sabu Thomas, the Vice Chancellor, Mahatma Gandhi University, Kottayam, Kerala. Dr. Lakshmi Raghupati, the advisor of our foundation, who was also the former director of the Ministry of Environment, Forest and Climate Change, Government of India. And presently she is a visiting professor at the Terry School of Advanced Studies. Our esteemed 6 speakers and 150 delegates consisting of plastic processor, MLP manufacturers, recycler dealing with the recycling of multi-layer packaging, the MLP waste, the brand owners, the polymer scientists, researchers, startup, students from India, and my friend from Mr. Anuradha Jaisinghe, the President, Sri Lanka Institute of Packaging from Colombo, the press, media, and ladies and gentlemen. First of all, on behalf of our Foundation for Innovative Packaging and Sustainability, FIPS, it's my great pleasure to warmly welcome Professor Sabu Thomas, the Vice Chancellor, Mahatma Gandhi University, who has kindly accepted my invitation to make his opening remarks during this inaugural program, despite of his busy schedule. In fact, I believe that he had just returned from his overseas trip. Probably this was his first overseas trip after the pandemic. Among all the plastics, the major growth is a rigid plastic material, including the PET of the packaging material, which is considered to be the most important. Today, we are very lucky to get the concurrence of Mr. Sabu Thomas, who has kindly agreed to be associated with us as a partner for organizing a series of the conference on the very important subject, the plastic packaging waste management. This series will consist of the three parts. The first part of the conference, which was organized by our foundation and also the MG University on 29 July 2021, and it was very successfully organized with the participation of more than 100 participants. And the topic or the theme of that conference was to how best we can make recycling as a profitable business. Having said that, a grand success of the part one, we have taken an initiative to do the part two, where we are thinking about the MLP, the multi-layer packaging, which is a very hot subject in the today's concern, and everyone is taking over the multi-layer packaging, how best it can be recycled and how best it can be managed. Today, all of us, we know that plastic is a wonderful material, and there is no alternative to the plastics material. In fact, if you look at about the consumption of packaging material, the more than 50% of packaging material is plastics, followed by about 35% of paper, and then glass, metal, and so on. Among all the plastics, the major growth is the rigid plastic material, including PET bottle for the packaged drinking water and beverages, plastic caps and closures with an annual growth of around 25 to 30%, whereas the flexible plastic has got only annual growth of 11 to 13%. But very interestingly, the flexible plastics material, which makes the multi-layer material and widely used by FMCG company, including the fresh milk, which are mostly visible because of their 5 to 7 color or excellent printing. And this has become a great concern to the society in India as well as overseas. But this is mainly lack of proper collection mechanisms which are implemented in the country, which leads to the problem of littering and environmental problem. Due to this fact, the government of India has also made a restriction on single-use plastic. But the question really lies here to who is the culprit and who should be victimized. Is it the plastic is the cause of environmental pollution, or rather we, the citizens, are the responsible for creating this problem? There's a great need to educate the citizen to change the behavior so that the post-consumer plastic waste material are collected properly, recycled, and converted into value-added products and not to be allowed littered. Considering this important aspect, it was thought that we need to address to the stakeholder about the science based on a science and technology, and also the good practices being adopted for the recycling of MLP in our country and also being made a value-added product. I'm really happy to mention here that we have got eminent speakers from the Nestle India, Uflex, Curare, Nature Preserve, Deluxe, and Libom Incorporation, who would be highlighting the technologies and also indicating about the success story, how really this problem of MLP could be tackled. I also welcome to all the partners, the event partners from the Curare, the Deluxe Recycling, and also Nature Preserve, who have been shown their keen interest to be associated with our foundation, and also the media partner, the Polymer Communic. He did a lot of work as a background to make the promotion and publicity about this event. Now, before I close, I feel to introduce of our team of our foundation. Priya, can you show the slides? As you know that this foundation, it's a very young, it was just taken a birth only in DCRA in 2021 with a theme of a knowledge platform, idea to solution. Next slide. The Foundation for Innovative Packaging and Sustainability, which was officially unveiled on 20th January 2021 by none other than the Professor M.M. Sharma, the Padma Vibhushan awardee, and Distinguished Emeritus Professor of Eminence, the former Director of ICT Mumbai, in the august presence of our two mentors, Mr. Rajani Ranjan Rashmi, the retired IAS former Chief Secretary of Manipur, and Dr. U. Venkateshwarlu, the Chief Secretary of Tripura. Next. I, along with my two colleagues, Professor Dr. Anup Ghosh, the professor from IIT, and also Mr. M.K. Banerjee, he's worked for 35 years with SL Propac, and both have joined, and we three have taken the initiative to start this foundation as a non-government and non-profit organization in 2021. Next slide. We have two mentors. We have been working and taking their guidance always. Dr. U. Venkateshwarlu, the former Chief Secretary Tripura, and Mr. Rajini Kanjan Rashmi, the former Chief Secretary Government of Manipur. Next. We have 6 advisors. At a national level, we have got Dr. Lakshmi Raghupati, the former Director of Ministry of Forest Environment and Climate Change, and she is also the speaker today and doing this her introductory remarks. We have a Professor Pradyumna Vyas, who is the former Director of National Institute of Design, Ahmedabad, and Dr. Anil Wali, the Managing Director of FITT IIT Delhi. We also have 3 advisors at the international level, Mr. Safiullah Chaudhary from Bangladesh, Mr. Dharma Ratnayake he's the President of World Packaging Organization and past President of APF from Sri Lanka, and Professor Shupraka Sinha Roy, the Chief Researcher, the DST CSIR from South Africa. Next. We have got 3 thought leaders, Mr. Abhijit Chaudhary from USA, Mr. Deepak Mehta, who is the speaker today, is also thought leader, the Managing Director of Libom, and Mr. T. Nagalingam, Managing Director from Chennai. And we got 3 chief consultants, the Rahul Bhargav, Chief Consultant Innovation, Mr. Bhattacharjee, Chief Consultant Training, and Mr. Deepak Manchanda, the Chief Consultant Packaging Design. Next. So with this introduction about our foundation, I once again welcome Professor Sabu Thomas, Dr. Lakshmi Raghupati, and all the speakers and the delegates for their kind participation to make this event a grand success. I'm confident that the technical sessions will be very informative and the participants will be highly benefited. Thank you very much. Jai Hind.
Thank you, Dr. Saha. That was an introduction to the theme of this conference as well as the background of FIPS. Now we are fortunate to have Professor Sabu Thomas of the Mahatma Gandhi University, Kottayam, amongst us, and I would invite him to make his opening remarks. Professor Sabu Thomas is the Vice Chancellor, Mahatma Gandhi University, Kottayam, Kerala. He is an internationally acclaimed visiting professor in polymer, nanotexture, and nanocomposites in number of international universities at France, Belgium, and Canada. He was professor in polymer science and engineering and also School of Chemical Sciences. He is the founder director, International and Inter-University Center for Nanoscience and Nanotechnology, fellow of the Royal Society of Chemistry, London. He was conferred to the Distinguished Professorship Award of the Joseph Stefan Institute, Slovenia, and he was awarded Dr. APJ Kalam Award for Scientific Excellence in 2016, and he has supervised 76 PhD scholars and leaders in a number of national projects. So, Professor Sabu Thomas, we invite you to make your opening remarks.
Very, very good afternoon to all of you. Professor Dr. Saha, Mr. Banerjee, Dr. Ghosh, Dr. Raghupati, Nurata, and all the distinguished speakers, participants. Let me first congratulate the Foundation for Innovative Packaging and Sustainability in organizing a series of programs in cooperation with my university, Mahatma Gandhi University, Kottayam. I'm extremely pleased to interact with this society for a multiple number of activities. I'm glad that under the leadership of Professor Ghosh, Dr. Saha, and Mr. Banerjee, they're organizing a series of functions for the industries, for the society, for the students. And they are able to bring excellent speakers all over the world and handling variety of important topics in the field of packaging, in the field of recycling. Dear friends, Dr. Saha has mentioned the importance of plastics for packaging. 50% of packaging materials come from plastics. There are a lot of advantages. They're lightweight, resistance to corrosion, easiness of processing. There are lots and lots of advantages for plastics. That's why plastics are being used quite a lot for packaging. They're quite cheap. But dear friends, if you look at the per capita consumption of plastics in India is only 12 kilograms. If you look into Singapore, their per capita consumption is 76 kilograms. When you go to Singapore, you don't see any plastic garbage. But I'm sorry to say that our country, including all the states, my own state, you can see a lot of plastic garbage everywhere. So we need to have a very good plastic management culture, recycling culture. I'm glad that under the leadership of Dr. Sahar, Dr. Ghosh, and Mr. Banerjee, you're organizing an exciting meeting on the recycling of multi-layered packaging material. Probably you all know that multi-layered packaging material is a very complicated material for recycling because you have multiple layers of different plastics. So you need to collect these materials, you need to sort this material, you need to clean this material, you need to separate different layers, and you have to go for recycling process. And you also have to incorporate compatibilizers. If there are multiple layers, you can recycle in a single step by using multifunctional compatibilizers. I remember I had a big project sometime back with Europe on the recycling of multi-layered plastic using multifunctional compatibilizers. A lot of chemistry, a lot of technology involved. And I'm glad that there are really good speakers to handle this subject. I was told by Dr. Saha there are 6 speakers across the globe. And I request all the participants to be very, very attentive, interact with the speakers, talk to them, understand the subject. It's a very, very important subject, very complicated subject. And I wish all the best for the conference. I request Dr. Saha, Mr. Banerjee, and Dr. Ghosh to organize a series of meetings for our students, for our academics, for our industrial personnel, and for the society. Therefore, a very good plastic could be inculcated in India, and plastic recycling culture could be inculcated in this country. Thank you so much, and I wish you all the best and good success.
Thank you, Dr. Thomas. That was very enlightening that we actually do see all the litter in our landscape, plastic litter, and there is an urgent need to inculcate the plastic waste management culture. With this, we move on to actually what initiatives FIPS has taken in this direction towards sustainability. And we have Dr. Anup Ghosh to tell us a little bit about the sustainability initiatives of FIPS in this direction. Professor Dr. Anup Ghosh is a distinguished and renowned professor in the field of polymer science and engineering at the Indian Institute of Technology, Delhi, and he's a fellow of the National Academy of Science, India. He has over 30 years of research, teaching experience, and has 12 patents to his credit. He is Director R&D of the Foundation, FIPS. He's known for his accomplishments in the field of polymer processing and rheology, significantly contributed in the areas of reactive processing of polymer blends and alloys, 3D printing of polymers and polymer packaging, and microcellular processing of polymeric materials. He has obtained his MTech degree in chemical engineering from the Indian Institute of Technology, Kanpur, and he is a PhD in chemical engineering from the New York University, State University of New York at Buffalo, New York, USA. He has worked as a postdoctoral research fellow at the University of Pittsburgh, USA until 1990, and then joined the Indian Institute of Technology in 1991. He is a recipient of the Teaching Excellence Award by IIT in 2015-16. So Dr. Ghosh, over to you.
Thank you, Deepakji, and distinguished members in the panel and the participants in the program. I will take you through the foundation activities that we are carrying out recently, involved in many number of programs, and in terms of the sustainability program that foundation is taking part in various activities. Can I have the slides, please? So let me take you through the foundation activities. We generally divide this into 4 verticals. We have skill development program. We are involved in research and innovation. We are in project and entrepreneurship and publication and policy advocacy. As you can see in the skill development program, we are undertaking a number of collaborative training and education program. You will see some of them. We have already taken quite a few of them completed. And we provide knowledge platform for industry and community, and number of awareness program on upgradation of skills and for the relevant to Skill India mission to make self-reliant. In terms of research and innovation, we have taken collaborative research on packaging solution, also in related to sustainability, research and development activities for involving new generation materials and sustainability, and supporting industry with innovative packaging technologies and number of packaging design services and solutions. Another very important area we are involved in, and we like to carry on more work on into this, is called the translational R&D, where we could help in moving lots of innovation from lab to further commercialization, where there is a lot of gap we feel in this area, and also to support industrial project on packaging of products, and also to help startup companies with packaging design and development and sustainability. Last but not the least, in the publication and policy advocacy, we are organizing research conferences and workshops, this program being one of them. And we are also involving in framework for circular economy, regulatory compliance and product stewardship, and also in design advocacy and the policy support. Next slide, please. And we put together as a kite module for the foundation, K for the knowledge platform, I for information technology, and E for the training and education program. As you can see that based on this information package and knowledge platform, we have already considered many programs like basic training program, elementary training program, advanced training program, entrepreneurship training program, and we have taken up quite a few of them already. We have collaboration with a number of institutions. We have collaboration with Northeast Center for Technology Application and Reach. We have collaboration of Mahatma Gandhi University, as Professor Sabu Thomas, Vice Chancellor, is already present here, and he has already mentioned, and we are very honored by that. We have program with NERIST in Arunachal Pradesh. We also have MOU with National Institute of Micro, Small and Medium Enterprise, in a MSME. We have MOU with the Foundation of Innovation and Technology Transfer at IIT Delhi in the similar area of work. And we also have MOU with the University of Science and Technology, Meghalaya. And recently we have MOU with the university colleges with in Delhi, which is Bhaskaracharya College of Applied Sciences in Delhi University. And also we have extended MOUs for 2 other associations, including PhD Chamber of Commerce in Delhi. Next slide, please. As you can see, some of our activities which we undertaken from February this year on food packaging, which has been taken, and also packaging innovation and environment that has been carried out with PhD Chamber of Commerce. Next slide. And in order to enhance the export market, we have importance of packaging for MSME, which has been taken up with NIMSME Hyderabad, and also on technology advances in food packaging that we had organized a joint program. Next slide. On the sustainability program, we had a program undertaken for a full-fledged course, which is having 40 hours lecture series, which has been taken up with the Bhaskaracharya College of Applied Sciences, with University of Delhi and the foundation together, and which was also supported by National Academy of Science India Delhi chapter, and which was completed very recently and is of huge success, which was attended by about 80 students all around the India and a number of colleges from Delhi and others. And this was the recently completed program that we have taken. Here also we have taken a series of modules to be conducted with the MTech, the EVMA All India Plastic Manufacturers Association and the foundation together in plastics and packaging. We have completed one on materials enhancing and marketability, and we'll be also in the coming months, we'll be taking up another module 2, which is on the environment and sustainability in plastics and packaging program. You can see our distinguished faculty, speakers, and the participants who were involved from various industries and the institution in this program. In order to bring this 2 days program, as Professor Shah was also mentioning, and very importantly, some of the important features were mentioned by Professor Sabu Thomas, that we wanted to, and we said that our theme is to deriving value from multi-layer packagings waste, and you can see that number of recycling possibilities in there in the post-consumer resin, which can be converted into as a packaging materials, and they can be the replacement of the virgin materials that can be used, and also number of compatibilizers that can be used, which can have value addition with the functionalities and developing into a valuable raw materials, which can be even used for upcycling, not only for downcycling. Next slide, please. And when we do that, as a part of our activities in the foundation, we are involved in studying the product life cycle, which involves from selection of materials, reduction of possibilities of optimization of the production technique, how we can see the efficient distribution system, which involves reduction in environmental impact, which can be calculated from this life cycle analysis procedure on the low energy consumption, clean energy source, consumables reductions during the use, and also we can go for optimization of initial life cycle and optimization of the end of the life system, and we take care of all these, including the recycling of materials. And in foundation looks into deriving the circular economy thinking in this way. We have taken a couple of programs where we look into material efficiency and the carbon footprint mitigation together, how they can help each other. And in that case, we can see that how we can bring the material developed, especially like a multi-layer packaging, and we can make the post-consumer recyclate from there, and they can be used as a replacement of the virgin material, and whether it can be done from the single family material, multi-family material, and they can be taken up from the life cycle assessment with the world standard of ISO 14040 or 14044, and this has been available with the foundation, and it can be taken up as very valuable activities of the foundation. Next slide. And to summarize, the FIPS activities on sustainability, it provides lots of opportunity for the circular economy solution to expand scope of recycling methods and across the plastic value chain that can be utilized. The plastic waste leakage into the environment is less desirable, and that can be see that what are the preferable methods to take care of that. Are taken up and can be carried out by as a part of the activities of the foundation, which involve establishing recyclable hierarchy. We can see that we can compare between upcycling possibilities versus the downcycling. We can see the effect of recyclability due to the presence of similar material and non-similar materials. We can look into that. Material reduction, especially in terms of thickness, versus the collection and recyclability from waste. In one or two projects, we are looking into that. We like to look into further into this. Material selection, where we can lower the number of layers versus higher functionality bringing in terms of compatibilization or some material addition. And there can be design for sustainability, And then the other area, there's alternative material synthesis, synthetic versus biodegradable or bio-based material can be looked into. So these are the activities that, and we like to emphasize on that and strengthen our activities. Next slide, please. With this, I like to thank you all for your attention. And you can look at our activities in our website, which is www.f-ips.org. I would like to encourage all of you to visit us through their website with different activities and connect us for further interactions. Thank you very much.
Thank you.
Dr. Raghupati was the former director of the Ministry of Environment and Forests, Government of India. At present, she is a visiting faculty in TERI, School of Advanced Sciences, in teaching solid waste management, waste utilization, and industrial ecology. She is a guide to doctoral and postgraduate students in TERI, and Amity University. She is an advisor and consultant in areas of environment and waste management, and also resource person in the Swachh Bharat Mission exposure workshops. So, Dr. Raghupati, please tell us your views, give us your views on sustainability. You are muted. Please unmute yourself. Yeah. Priya, can you
Yeah, I've done it. Okay. Good afternoon, everyone. Since all the narrations have already taken place, I have very few words to speak. So just to set the ball rolling, I wish to say thanks to Dr. Narayan Saha, who has invited me to be here to introduce the subject. I also acknowledge Dr. Sabu Thomas to be here, and all the others are colleagues of my foundation, and also the eminent speakers who are going to be there. So first of all, this is a session on multi-layered plastics, which is the last evolved plastic, which we can say, because the plastic, the wonder material, was introduced in the 20th century, and it has really taken us by storm, because now today we feel that nothing can be done without plastic, because plastic is such a material which has multi characteristics, and it has so much of endurance and capability. And only thing that I feel is, when we say MLP waste, why should we say waste? We are trying to make it into a resource. So we are going to in the long run, we are going to make it achieve milestones to make it into a resource, so that in the whole philosophy of sustainability and circular economy, we don't want any waste. We want everything to become a resource. So we will close the loop, the plastic loop. Similarly, we are hoping also for the multi-layered packaging, which is actually a composite material, but it provides a very good barrier. It has strength, it has a storage capability, and it has stability. And to top it all, it is most desirable material for food packaging, as well as the pharma, the medical uses. So it is inevitable to really easily replace it with anything else which can meet all these qualities. It has to meet the quality of the temperature. It has to meet the quality of the moisture. It has to meet the quality of having long shelf life. And also, when it comes to the multi-layer packaging, we are looking at some other aspects of multi-layer packaging in industry, where we use it for the hazardous material. And that's very essential, because no hazardous material should leak out. It should not leach out. It should not come out of its package. So that's why the packaging, and the most endurable packaging, is the multi-layer packaging. Now, when it comes to the regulatory, I will only focus on three things. One is the regulatory focus, because we have amended the plastic waste rules. The plastic waste rules, which was only focusing on the polythene bags, but it has now it does have a focus on non-recyclable multi-layered plastics, which were there, multi-layered packaging material, which was there in 2016 amendment to the rules. Then in 2018, further to that, it was also mentioned that it should be the one which is not even recyclable, not recoverable, etc., etc., but with no alternatives. But then in the 2021 amendments, they have also excluded the multi-layered packaging for the imported material because there is no replacement as yet. This is the struggle which is globally being understood. So they said it cannot be so easily replaced. So we need to find ways and means. And I know we have speakers who will be talking about it, who will be actually telling how they can manage it and what are the products or what are the outcome of recycling that you can do to bring some product which will be replacing the other products like wood, etc. So that will be one of the very useful things. And as far as the developing country is concerned, it has a very not only developing countries, I'll say mostly for India, because we have a very good idea for putting things back in cycle. The circular economy or the use of waste or not making anything waste in the first go. When we talk of the single-use plastic today, which is supposed to be phased out, we were not very favorable on this single-use plastic. And a lot of single-use materials came for the medical practices because we wanted to have a safety in the practice. We didn't want to use the syringes, glass syringes to replace with the plastic ones because plastic has to be thrown out. So they thought it is safer to throw it out without reusing it. So that was one of the things why many of the things got replaced, because they thought if you use once and discard it, it becomes safer from the medical point of view, from food point of view, from others. But then today, when we look at the multi-layer packaging, we have many issues in that. One is that how the packaging material has been made. That has to be traced back to know how do we repeal it, how do we make it separate the layers, or are we going to just shred it and put it for some other purpose like road making or strength or construction material, which will be strong enough because of the multi-layers. So the metal, the plastic, the paper, the materials that are fused together to make this multi-layer packaging is not an easy game. But let us see, because there is a lot of ventures going on across the globe to see how it can be recycled. And the recycling has been made possible because there are certain techniques being evolved. I think Dr. Ghosh knows about it, that they are trying to see how we dissolve each of the layers, or we intervene the layers we create the porous layers such that the material penetrates into it and it automatically separates. So these were one of few of the things where we see if we have a metal, plastic, paper combination, how do we do it? So when we look at the multi-layer packaging, it's not so it's not so easy to evolve a single track mechanism. So each material has to go studied, and as Dr. Ghosh pointed out, we have to go to the life cycle analysis to see what are the constituents in it, and then we go for the scientific method for taking care of it in terms of recycling and processing. Now, as far as the policy is concerned, the rules are there, but the rules are having one more thing, that is EPR, Extended Producer Responsibility, like Pepsi, Coke, etc., who came forward for the PET. We have Tetra Pak who came forward for the multi-layer packaging, but still they are struggling. They've not really achieved 100%. They are doing very good. But when we talk of the circular economy, we need to put back everything in cycle. Let us see how we can do it. And some of the prospective people who have recycled, who have certain things to share with us today, will really reveal what is there. Apart from that, we have a couple of guidelines, couple of documents which have been put forth in the websites, in the media. But I find that many of them have not really gone threadbare into the details of multi-layer packaging, because there's a lot of scope to do, a lot of research, lot of innovation, and then we go in for that. So go in for really bringing a final solution for multi-layer packaging. But let's not call it waste. Let's say multi-layer packaging material, or used multi-layer packaging material, or we say post-consumer multi-layer packaging material, which can be taken back to put back in cycle and recycling. Thank you very much. I don't want to stand between the excellent presentations that are waiting for you with the wings. So thank you very much.
Thank you very much, Dr. Raghupati, for so perfectly setting the stage for the technical presentations ahead. And the challenges that are faced for recycling of MLP materials. With this, we are going straight into the technical session. As it happens, we are already running behind schedule, so we'll quickly move on to the technical session. Dr. Saha, from here, please introduce the next session and move on.
Yeah. Thank you, Deepak ji. I think we're going to start the technical session. And as he said that we have a series of speakers, and this subject being a very important and very hot subject in the country and across the world, we have got speakers lined up. Our first speaker is coming from Nestle, he's a brand owner, and followed by we are from Uflex, and we'll be talking about the recycling technology. Then we got Kurare. We'll be talking about what is the innovative solution to make really multi-layer material to make a single layer. And then we have Mr. Bomit he'll talk about how he's really doing the recycling board and the two different technology. And then finally, Mr. Deepak Mehta will be talking about what are the challenges really to do the recycling of MLP. So I'll start with the first speaker who is with us, Mr. Burun Banerjee. I think all of you know that he has been working in this multi-layer packaging, recycling, and very promptly, very aggressively, and as a front runner of this subject. Mr. Burun is a postgraduate from the Indian Institute of Packaging, Mumbai, and he started his journey in packaging for the last 25 years back, and the research associate with a pharma company called Ranbaxy Laboratory, and today now called as a Sun Pharma. And during the last 26 years, he has a very diversified experience in the different FMCG company, pharmaceutical, and experience in the core subject on the packaging. And he could understand then how important the packaging for the people life. At present, he is working and trying to spearheading that Nestle India packaging function. And he believes that there are so much to contribute as a packaging professional to the world of packaging. He believes that this is the first contact point and sold to every product. And as a packaging professional, he's confident and he's believed that packaging should exceed the consumer expectation and it should guide to develop the first time side or the safe packaging. With this, Burun is going to talk because he is the only person representing from the brand owner. And whenever we talk about MLP, whenever we talk about ERP in the government notification, which is issued by the Ministry of Forest and Environment, everybody is concerned that what the brand owner is really going to do. But I'm sure that Nestle India, over a period of time, they have done a lot of work and they have done a lot of trial. And this is the position of called transition about how really they are going from multi-layer packaging to mono-layer material. And that's the topic is called the brand owner perspective, the transition from MLP to MLM. And I believe that Burun is the front runner on this subject. So I request now Burun to speak for about 20 minutes on this subject, what all his journey in the Nestle India to convert MLP to MLM. Over to Burun.
Yeah, good afternoon, Professor Saha. Good afternoon, Deepak. Good afternoon, all the members of FIPS and all the distinguished speaker. It's first of all like to congratulate FIPS and also like to say that it's a really apt topic and the subject which we are taking it today in the session, because we have regulations, we have amendments, we have also the draft national framework, EPR framework coming in. So we all know that these are the requisite which we have to comply with. And at the same time, we know as a country, how do we really manage this waste, which is today we are managing the plastic waste to a tune of 15%, somewhere we know the data. And how do we go in 2025 to look at the MLP management to 30%, although the plastic recycling is at a 60% rate in the country. So overall, I see that what Dr. Sabu Thomas and Professor Ghosh and Dr. Lakshmi Raghupati mentioned, that how do we make MLP not as a waste. It is a fantastic material, but we also should treat it as a resource for circular economy in the both recycling, reuse, as well as reduce point of view. How do we make it use of 3R in the whole process? So I'll go straight over to my journey as Nestle, how we are looking at sustainable packaging, the entire journey in the Nestle world, and coming to the developing market. What are the next steps for us? How we meet up our commitment, which we have in 2025, as our vision that none of our packaging, including plastic, ends up in landfill or as litter. This is something which we know as a country where we have to really develop the infrastructure, first of all, to really meet up to make up this requirement. So going straight, how we took it, because in 2018, the regulation amended that multi-layer plastics has to be recovered through, energy recovery is accepted, as well as through cement clean, how we use it, this material. We started this journey that, okay, right now we'll be doing a recovery route, and we should look at more innovative packaging format solution or a structure solution. So request Mr. Jignesha, if you can mute your mic. There are disturbances. Thank you. So going forward, we had the drivers, which Nestle Global Commitment we did, and also the Indian regulation which came in. So with Indian regulation, we were also looking at our golden rules very clearly, which is based on rigid plastics, which are the really the material which should be doing usage for us, which we looked at a lot of restriction. Do not use fillers in it, so that it helps in recycling. Similarly, we looked at more of same material, which is a single polymer based structure. That was our way of looking at it. And then we also looked at prioritizing this single polymer structure from multi-layer structure. We are saying that how do we really, these are the golden rules which we came in, which we had even with our partners, we started sharing and we started working with them, as because it is nothing to look at that what other industry, it is sharing and doing the approach that we should all go together in the field of recycling and making the country looking more recycle friendly solutions. So that's how rigid plastic we took. Similarly, multi-material, we started looking at it. MLPs, which are difficult to recycle, like the ones which is with foil based, can we look at a more simpler structure? With we also look at how can we look at the shelf life of the product to the consumer. Do you need very high shelf life? So can we fast track our the distribution network to see that you shift the barrier also, so that we don't really use that 18 months. So our timelines, we would like to, the shelf life can be between 10 to 12 months to 15 months. But beyond that, I think we looked at some of the areas where we should work on the material to see, do we really need to give long shelf life to the product? Then we also looked at the monomaterial, the flexibles, plastics itself, how we should start using on the shrink sleeve, stretch film. So all the combinations where we look at it, that is there an alternate way to develop material? Do you really need same material? Do we need simplification? Can we use post-consumer recyclable shrink film materials in the shrink film, stretch film applications? So these are some approach which we took as a golden rules. And then we also looked at the negative list, which we actually looked at. The definition of negative list is which are difficult to recycle. Those materials we need to start phasing out. Similarly, the master batches, which we have carbon blacks, which will have a difficulty in segregation process in NIR technology. So how do you really look at this? PVC shrink sleeves, PVC, polystyrene. We have to really build up this infrastructure, or we do have to find a solution to have an alternate material structure. So these are the timelines which we are doing it. Happy to share with all of you. We are the first company where we moved the integrated paper straw in the market, and that was a real challenge to have a U type of paper straw for Tetra Pak. And this Nestle took as a first example globally. And we for the entire Southeast Asia region, now we are moved all to a paper straw. And the next step which we are doing is moving to a paper wrap also. So we are also piloting paper wrap with paper straw, so that the whole Tetra Pak, this litter situation for the straws are definitely have a clean solution on the paper straw with going for paper straw. Then we also looking at master batches, lighter color master batches. Wherever possible, we go down to the lighter colors for easy recyclability. We are also looking at reducing colors in the packaging. So how can we move fast from 8 colors to again a step forward to look at 4+1 CMYK plus 1 color, which is more regular ink color, so that even that helps in recyclability. So all these actions which we are combining from, as Dr. Lakshmi Raghupati mentioned, that it is a composite structure. We need to really see how this composite structure can be made simplified to have a better recyclability in the in our context of recycling process, which is getting developed, and sooner for the circular economy also. If we go to the next slide, please. Yeah, this is the getting into action, how we really did it. So there is a team formation which is very important, core team, and the which includes, we have to have the single point of contact at factories, because we have multiple factories. We have to have a real one spot for the technical support, R&D centers, coordination. So this is how a team is first. It is very important to do the proper planning and the team. Secondly, we really looked at all our converters, who are working on multiple material suppliers and converters, who has also, we looked at the certificates from CPET on recyclability of the monomaterial. So when we were designing this, we know that every solution for MLP is not there. So multi-layer plastics would be there, and multi-layer plastic where we see that we can simplify the structure of monomaterial, we should start looking at it, because there was a clause in the plastic waste management rule that how can you innovate your structure to have a better recycling rate. I think that's something which we are working on it. It's a journey, but definitely we would see that what are the solutions around it, because different product needs different barrier, and different oxygen and moisture barrier needs different structure. So every solution we will not have it, and that is where some supports, some technology which FIPS is mentioning on the kite modules. I think that is the way forward. You have to do research in this area, and that too in a local context. What is available? What is our raw material? What is our partners have the facility to really convert it? And that is how we have to develop the further solution into this monomaterial journey. The roadmap which we did is identifying the priorities. Then we see that the category also with business, we discussed each of the categories where we can look at it. Later, if there are solutions which is around paperization, that would be the things which we are also in parallel looking at it, where really you don't need it, and with a lesser shelf life, if you can go into a paperization solution. As I mentioned, negative list, material difficult to recycle, we had to phase out, we had started put in our roadmap. Then the cost was also a key factor. We had to see that between the cost benefit analysis with the material, because we cannot really pass it on to consumer. We have to really design in a way that we reduce the size of the packs, so that much material we can also save in the format, which can also help in the putting the structure cost in the material. So this is a way, and then we took the trial protocol with the key success criteria as how we should ramp up these trials. It should not be like we took a smaller quantities, we looked at it in different machines, different config. We have a different types of machine, different speed of machine, different performance of machines. And I'll go to the next slide where we have looked at how those are the machine improvement we had added in our development also. So here we also had learn, unlearn, then relearn, sharing the learning also with the learning log with other factories together. You know, it is not a easy journey. It's a complex structure. So we need to see all the process parameters with our partners, upstream raw material, as well as with our converters together. We also need to look at all the success criterias which are mentioned, like seal integrity, which is first thing, so that our pack doesn't open up. Warehouse cross checks, which are very important, because when you produce in a multiple numbers, you have to do a lot of checks to see that your packs are defect free. Because when you look at monomaterial, you will also see that this has a lesser, seal strength to the level which is optimum, but at the same time, when it is really going through the transport stress, are they able to withstand? So seal integrity is good, but then whether it is able to handle all the transport test. So this is the area where we did, and we thoroughly undergone the text. And second, another area where we saw that defects level in the sigma level, how is your packs in the sigma level, the defects between the current and the new structures. Similarly, the storage of BOPP although it is a multi-layer and it is a monomaterial, but BOPP, CPP, and this material storage is very important. Storage time, conversion time, all this needs to maintain. We also looked at all the machine stoppages, analyzed it, then we did the transport test to see it. So clearly we had shrinkage, we had burning, wrinkles, we had to see that temperature, you have a narrow bandwidth. So we had to do necessary sealing curve to really define where exactly our machine should match with the material structure. We had done this modifications on the line. We had changed the jaw home position, which is very important in plastic, where when you look at a polyester poly versus a BOPP structure, little temperature, so you have to open up your jaw. When it stops, the line stops. So otherwise it will shrink, it will burn. So these are the modifications on the machine was done. There was nichrome strips was added so that when the jaws are opening up, it will not give us the temperature heat in the long sealer. The rollers disengagement has to happen. These are the the learnings which we saw, because and these are the ones which are also incorporating in our new buying of the machines. Whenever we are buying the new machines, we have started looking at all these learnings to be put in the new machines whichever we are buying. We are going to the extent of looking at the machines which can even handle a strong paper-based solution at a later stage. So the work has to happen proactively. So that is the learning which I want every participants from the other industry also to note, that the journey is definitely challenging, but you will definitely also have a reward and accomplishment once you really look at these material structures. And once your machine modifications happens, you will be able to move into a structure which is more environment friendly structure. I think this is the key message which I want to give. But consistency, process parameters, which many times in the multi-layer plastics, we see that there is a lot of window to play with. And that's why I also strongly look at that multi-layer plastic. Everywhere we have to, when we go for this change, we have to now find out how can we increase our sealing range in the monomaterial. That's something which you have to work and see in the research. How can you expand this sealing window in the material? So next one, please. Next slide. So we had also done the chocolate wrappers, but I've seen less challenges in the cold seals. And cold seals helps a lot. It doesn't have much because the temperature is the biggest, challenge or enemy for BOPP kind of material in a fast, high-speed machines. So cold seal we could do faster. What only changes which we have seen is storage condition, printing quality on the OPP structure. You have to make new cylinders. Some of the compliance documents we have to look at it. And then the maintaining the supply flow from upstream to downstream, that is the converter. This is something which you have to overall manage much differently than the other ones, the MLP structure. So then this is the sharing with other factory locations. It's very important because people has to really get into this learning curve faster because it's a more complex material than the MLP structure. Next slide. So just a glimpse of them. Even we have looked at the ones which litters, the BOPP tapes. So although the shipper is paper, but the tape is loose and it is thrown. So how do you really, even that particular material, we used to use paper stick tapes. We went out of the paper tape. So this is one example where we restarted looking at bringing back the paper tapes, which is a very simple one. And that can be, because the papers are being recycled. So with the tape in it, it always becomes a difficult and that becomes a litter. So as a waste management, I think this is a very good solution to work on. Next, please. So I will not like to, this is a simple EPR, which is the compliance where we are plastic neutral from 2020 onwards. And that's proud to say that we have managed plastic very well, which we produce as a post-consumer. We are doing complete recovery as per the plastic waste management rule regulation. And we did engage multiple stakeholders to really see different areas where we can recycle. And we are also working now on the pyrolysis, which could be another area where if it works, it would be the right approach to the circular plastic circular economy to go back to the virgin plastics. Now with the new regulation coming, I think with the using of recycled plastic, I think it's a very good news for all of us. We need to, all the brains has to work towards the right standards, which can really bring in this recycled plastics usage by 23-24, which the guideline is talking about. I think it would be really good that we all bring this up and a BIS standard is created so that we can follow this in our food packaging. Maybe start with indirect ones and then go for the direct food packaging solutions. I think that would really help the industry to manage the waste properly. Next one, please. Next slide. So final key points: collaborative approach for environmental system solutions. Encourage material structure which are recycle friendly. Need strong research to develop single layer structure. And there I would really see that FIPS plans, which is there in future, to collaborate. All brand owners should start moving to recycling and to get better value for recycling. I think that is something which will help in a later stage to see how it works. Need of the hour is plastic circular economy. I think develop infrastructure to recycle packaging. This is something which is the need of the hour. Different technologies has to be explored in around that. Discourage difficult to recycle polymers which are while designing the packaging itself. I think we should look at those during the designing of packaging. Government through recent amendment has took a bold step to encourage use of recycled waste in a phased manner. I think there the standards needs to be designed, which I already mentioned, and reduce virgin plastic use. I think that's a great step forward. Clear labeling has to come to communicate use of about this, that we are using recycled plastic to that content. And finally, EPR to continue its zonal approach and through plastic credit. I think that is how we'll be able to manage more effectively. Although we did our circular economy, we are doing our plastic neutral positive 100%. We are doing work on the hill station also, but this is the approach. Zonal approach would help definitely. With that, I thanks Professor Shah, thanks everyone that you have given me the opportunity to share the MML challenges to convert from MLP. Thank you so much.
Thank you, Burun. I think it was an excellent presentation. And I should say it's a true technical and a scientific presentation. Everyone, the audience would know that packaging is not just wrapping the product. It's a combination of the science, art, technology, and of course, economics. Burun was trying to emphasize that what is the journey that Nestle is doing from the MLP to MLM. Very frankly speaking, the multi-layer packaging, it is really by the compulsion. None of the brand owner is interested to use more and more packaging material. Rather, they are considering sustainable approach, the resource efficiency. But the problem is it has come by the compulsion based on the food product. Some products are very oxygen sensitive, moisture sensitive. You need to have a barrier properties. Single layer may not have an oxygen barrier, moisture barrier, sealability, printing, transparency. If you really want to satisfy the consumer, you need to have all the aspects. So what Burun was trying to say, his journey from the Nestle, that from multi-layer to the single layer one they are going, they have a lot of challenges they are facing, start from the seal integrity. At the same time, they have to also say that transportation hazards, how really it would function. But very interestingly, he said that a very simple solution, they start with a tape, which is a very closing tape. We say that as an ancillary material, I think Nestle has already switched over from the plastic tape to the paper tape, which was there about 30 years back. He has come back, and that's the small way they're trying to have a sustainable approach, and this is the way going. And more interestingly, what he has emphasized, that a journey from multi-layer to the single layer, it's not an overnight journey, it's a long journey. It needs to be researched. And what I'm very happy the brand owner is showing, they had already a dialogue with our foundation, and we'll be very shortly taking up a research project, how really multi-layer can go to single layer with a different recyclability. Today in the country, there is nothing called degree of recyclability. Different material has got a different recyclability. That kind of science and technology-based research need to be done, of course, related to the life cycle analysis, which we'll be doing. And finally, he says the PCR material, it's a good step to what government is trying, but it has to be done in a very phased manner. From non-food is very good, but straight we're going to the food contact application will be very difficult, thinking about the safety aspect of the food. But as he said that we can have start with an indirect food contact and then slowly go to the direct contact. I think that's the approach it has to go. So overall, I feel it was a very nice presentation and very technical and truly the packaging presentation what he has done. Thank you so much, Mr. Burun, and a big round of applause from the audience. Thank you so much.
Thank you, everyone. Thank you, Professor.
So we move on, as we are all talking about our waste is not really waste, it is a resource. And we have with us Mr. Jivraj Pillai. I think he does not need many introduction because he has been a speaker in many international and national forum. He belongs to one of the largest laminate manufacturer of the flexible packaging called UFlex Group. He is the joint president of packaging and new development from UFlex Limited. Mr. Pillai is a mechanical engineer and a postgraduate in business administration, over 34 years of experience in packaging. I know Mr. Pillai almost for the last 30 years, and since he is working from our UFlex Limited, he has taken up many more initiatives, how best we can start the multi-layer material to recycle, biodegradable option, the enzyme-based polymeric material, how really can do the energy curing technology and so on. And he has presented many papers on that application of E-beam technology, anti-counterfeiting option, anti-microbial film, how it can be doing something called active packaging. All these new initiative from the UFlex, he is the pillar behind this company and who has been started. With his a large and huge experience, I think it's the right time to invite Mr. Jivraj Pillai to cover the subject called recycling technology for MLP, which is not really a waste, it is a source of wealth. Over to Mr. Pillai.
Thank you, Dr. Saha. I hope I'm audible to everyone.
Yeah.
Okay. What is the time limit?
20 minutes.
20 minutes. Okay.
Yeah.
So I'll plan that way.
Yeah.
Can somebody give me a sharing option, please?
Yeah, you can. Priya, you can give sharing. He can do on his own.
Okay. Has a presentation come up?
Yeah, it has come out. Yeah.
So for most of you all know what is multi-layer packaging, and as Dr. Saha had explained, at this stage it is not very possible to completely change over to mono polymer materials because there are multiple layers in a MLP, multi-layer packaging, which provides functionality. And in a true sense, if you have to be sustainable in packaging, we have to address the multi-layer packaging, because see, whatever we have done in the last 3 years or so, after Prime Minister Modi had made a speech from the Red Fort, we have addressed only the single-use plastics. So single-use plastic, although it is an eyesore and you find it everywhere, but in terms of the percentage of littering, it is far, far very less. The consumption of single-use plastic would be around 15 to 20% of the total packaging consumption. So we have been talking to the MOEF saying that, let us address MLP. If you're really interested to address the plastic packaging, plastic waste issue, then you have to address MLP, and addressing MLP is obviously not easy. If it was easy, probably other countries would have adopted it significantly faster than what we are trying to attempt. But at least in this EPR, an attempt has been made. And basically, why there was no attempt was that we talked to a lot of people in technology, in MOEF, and they really were not aware of the recycling technology of MLP. Till 2 years back, or probably 3 years back, everyone thought multi-layer packaging with all plastic layer would remain non-recyclable because of various combination of material with different rheology. This is not true, actually. We have been doing recycling for the last 25 years of multiple polymer material. Just last year, the COVID year, we recycled something like 20,000 metric tons of MLP. Surprisingly, out of 20,000 metric tons which we did only 5,000 tons of, approximately 5,000 tons of PCR MLP, which would bring us to the point that actually the multi-layer plastic waste is not available for recycling. We were talking to the NCR region, and they could hardly provide us the MLP we wanted. I'll give you a small breakup of 5,000 tons of PCR. Out of the 5,000 tons of PCR, less than 1,000 metric ton was contributed by Noida Authority, where we are placed. So, and if you consider all our plants across country, Jammu, Haridwar, Malanpur here, we got regional support to a tune of less than 30%, which means that there is an issue with collection. We had to get MLP waste, PCR MLP waste, as far as Trivandrum, Karnataka, Guwahati, So, and imagine the freight cost we had to pay, So, MLP is a very light material. In a 10-ton truck, you will hardly get two tons of material. So, and the truck would cost 85,000 rupees to bring from south of India. So, this is actually the point that although EPR talks about recycling in this edition of EPR, the collection will be a major problem with every brand owner. Unless we have a collection system, MLP recycling would be a tough task, because it will not be available. Having said that, I'm here to discuss how we can recycle multi-layer packaging. I thought I'll just make this passing remark in terms of, if you have to address sustainability in our country. Let us talk about the multi-layer packaging, recycling. So the Indian multi-layer packaging is very different than the ones available elsewhere. The PCR MLP, which is in India we have, is very, very different because we use a lot of oil. And also, since source segregation is missing, we mix the multi-layer packaging waste along with the food. Now, as a result, the food has to be separated from MLP. So this is why what you are seeing on the screen is a very complicated washing system. Normally an MLP line, I've seen one in Poland, it is not so complicated. Here you will see at least 5 different types of washing. There is a friction wash, there is a rotary wash, there is a reverse screw wash, there is a hot wash, there is a caustic wash. So this is designed for the Indian food, the Indian MLP, I would say. MLP is MLP everywhere, but the PCR, when it comes to PCR, the Indian PCR MLP is widely different than the ones available. It is slightly closer to China. China also uses a lot of soya oil, and but they have a good source segregation system. So the plastic packaging is available in a manner where organics or the food is not involved. In this case, we had to develop a shredding machine where we had to remove the food first. The food is almost constituting, if I buy 5 tons of PCR, I get at least 2 to 3% of food in that, in terms of oil, salt, spices, leftover chips, leftover food. So you need to wash them thoroughly. So this is a washing line which we developed in-house and to wash the PCR. Now, once the MLP is washed out, the most important thing is it goes through a multiple washing cycle. So there is a lot of water. So you need to dry them out. So the challenge was how to dry this MLP very clean, because any amount of hot air you pass, there will still be moisture which remains in the washed mix. So we had to develop a squeezer. What it does is basically it squeezes out the moisture and makes lump out of the multi-layer plastic. So the output of the washing line is not a shred, a washed shred or a dried shred. It is a squeezed out material. So this was a very important innovation which we did, because the squeezed out material has less than 2% moisture. And this enabled the multi-layer packaging, recycling of multi-layer packaging without much issues, because moisture is a big deterrent for any recycling technology. So once it is done, it was very easy. We could recycle and make thousands of components from the MLP. We will see a small video. This is a live video which is from the Noida operations. I hope you can see the video. Hope everyone can see the video.
Yeah, it's working. Is there any sound, Pilaj?
There is just a music, but which can be ignored, So,
Okay.
So look at the waste, quality of waste. The rack pickers pick it up from the nalas and the roadsides. So from this condition, you have to bring it to a recyclable condition. So you see, it's first it has to be shredded. So it goes through a multiple washing cycle. So this is the cleanest material which we can get after the washing. There is a last wash which is called a caustic wash, where it removes all the oil. And finally, it is loaded in a reverse manner. So the water flows in one direction, the material moves in one direction. So this is the squeezy which I was talking about. This is the squeezy material. So this is the catch. So the material is now a conglomerate, is a composite of different types of material, inks, adhesives, metallization. Everything is squeezed out and mixed properly. So instead of feeding the MLP directly to the extrusion, this is being done. And the extruder is divided into 2 halves. So first is a mother extruder, where we use a very larger screen size. So it's a mother-daughter extrusion, where we have 2 different types of extrusion L/D ratios, so that you get a very fine mix of material. And you see the quality of granules. When you saw the quality of the input and now you see the quality of the granules, very, very different. Now you can see thousands of materials which are components which we have made, mixing up to 50% of the material. This is the chair which is made from 50% of the virgin material and 50% recycled. So very important that so this is the technology which I was talking about. So what we do is, and this is in a public domain, there is no proprietary information, and we are very open to providing this technology to any which one who wants, actually. So first you have to shred and compact. Then you add a compatibilizer. So as I said, you know, India is predominantly a polyester-based MLP using country. You know, so if you take 125 million tons of flexible packaging material, almost 70,000 tons, 70 lakh tons of material is almost coming from the polyester range. So, and polyester and polyolefin both have different rheology. So you need to compatibilize it. So there are compatibilizers available. Earlier it used to be only from DuPont, but now there are many companies. There's a company in China which is called Lushan. They also make very good compatibilizers. You send it to mother extruder. Mother extruder has a larger screen size. So you remove the volatiles which are caused from the inks and adhesives. So all the volatiles are removed. Then it is sent to a baby extruder with a very fine screen because the screen size will determine the moldability. So this is very important. And in both the extruders, we have multiple degassing facilities. There's vacuum degassers, which remove the volatiles. And then, of course, the cutting, you know, since there is a lot of polyester, you are not able to make the strands. So since you are not able to make a strand, you cannot use a circular cutter. We need to go with a die-phase cutter. And the die-phase cutter also needs to be immersed in water. So this is very critical. So basically 3 technologies. One is compatibilizing, second is removing volatiles, and third is the cutting. So with these 3 technologies, it is very much easy to recycle multi-layer plastics. This was not a cakewalk. We started working from 1995. We would have broken at least 30 to 40 screws, different L/D ratios. There was nobody in the world who could make the extruders for multi-layer packaging. So we had to really indigenously keep developing the barrels and the screws multiple number of times. Finally, we hit upon something where we could recycle the multi-layer plastic very successfully. So this is the technology which can be provided to anybody who wants it, because I was making a calculation. If EPR, the latest EPR has to be implemented, and if MLP has to be recycled, India would need over 500 recycling systems in 2022-23 alone. And right now we have less than 50. So you can imagine we need to take this EPR guidelines very seriously, start investing. We need to have more and more recyclers coming forward, more and more brand owners coming forward and promote MLP recycling, so that when the EPR is in place, you don't have to cross-subsidize the EPR collection and recycling. So this is very important. We must start focusing right from today. A little bit of FAQ. Is it really essential to have only a monofamily material? No, not at all. You know, you can have multiple materials. Only difference is, if it is a mono material, you can upcycle it. You know, we have made PE films with up to 20% PCR. We can go up to 30% PCR, but 20% PCR has very little drop in the mechanical properties. Recently, we had trialed some diaper bags, and a lot of course, carry bags can be easily made. Stretch film, you know, so somebody talked about stretch film. The stretch film with 20% PCR easily made, you know. So things like that. So monofamily material will only enable upcycling. Other than that, if it is a multi-layer packaging with multiple polymers, then you'll have to go with the molding applications, downcycling. What are the envisaged applications? You can have a lot of applications in molding. In UFlex, we have 14 film lines, and all the film lines use cores, you know, the core plugs. All these core plugs are made from recycled material. So we have a consumption of around 3,500 tons of core plugs alone. So out of the 20,000 metric tons of recycling we do, 3,500 metric tons is consumed in-house. So this way, you know, a lot of materials can be consumed by the brand owners. Say, for example, Procter & Gamble, they make a lot of tubs and the scoops for the detergent. Everything can be made with recycled material. So the brand owners, the brands can themselves find a lot of their applications where their own MLP usage can be extrapolated and used up. So this is very important. Technology support, if required, we can give you the technology support, but it is already available in the open, in the public domain, because the people with whom we developed the extrusion lines, they are already having this in the market now. Very simple, we already discussed about it, so not much detail. Self-sustain, yes, this is very important. This plant is self-sustaining plant. Imagine we invested over 20 crores of rupees in recycling technology. We would have purchased 2 printing machines and would have developed 500 metric tons of laminate. But we focused on recycling, spent about 20 odd crores in recycling, and the whole project is sustaining with a payback period of 3 to 5 years. So depending on the waste available, it can be recycled, and the project can self-sustain and pay back in 3 to 5 years. Lead time is not very high, and the investments are not very high. It's about 3 to 3.5 crore. You can have a 2 tons per day production line. People talk about paper substitution. Many companies I have been talking to, everyone knows paper is not a sustainable material. So please refrain from going into something unconventional. One more important point is that my advice to the brand owners is that don't try to reinvent anything. Right now, packaging enjoys a beautiful equilibrium. The Maggi has a packaging material which is suitable for Maggi, a milk powder, or a detergent, or a chocolate. So right now the machines are well aligned, the packaging material is well aligned, the speeds, productivity, the cost, everything is well aligned, and they are into equilibrium. So let us try and find a way in this existing equilibrium how to get into circularity instead of inventing new things. As Dr. Saha had said, monopolymer material is a very good idea, but it might take some more time. And till that time, the surface of our country would be full of MLP waste all across. We installed an MDO line about 6 months back, and even today, the line is running idle because the monopolymer structures which we developed did not meet all the expectations of the brand owners in terms of speeds, in terms of seal releases, in terms of barrier, in terms of other functionality. Yes, this will come. This will take 3 or 4 or 5 years time. But by that time, our country will be full of filth around. You cannot move out of your house. You move 100 meters and you will find a garbage of plastic waste. Unless we develop something to remain in circularity in this existing equilibrium. Thank you so much, sir.
Thank you, Mr. Pillai. I think it was a eye-opening for a new investor. I think they should realize. I'm sure many of the brand owners is really thinking about how the EPR compliance. But I think Mr. Pillai has given very broadly the idea that there are a few interesting things, and I think it's an eye-opening for us. There is a shortage of MLP. And really, he has to get the material from South India by spending a lot of expenditure on the transportation. That is one. The why is a shortage, because if you really want to convert it as a resource material, not as a waste to a valuated product, you need a lot of MLP, which is not there. The other interesting part he has highlighted about the contaminated MLP. Unlike the European food, which are non-oily food, and they use a lot of dry food. And in Indian cuisine is like that. We have a lot of gravy and oil, and that's the way the MLP, what he gets with a lot of residual food, oil, the contamination. As a result, his washing line becomes more complex and more complicated. And what the experience and what the UFlex has really developed, the new technology which he hasn't highlighted, but he has finally has given a few messages saying that if really EPR need to be implemented, we need to create an infrastructure facilities in the country. He has his ballpark figure about 500 recycling unit. In India, we got less than 50. So when the government is trying to implement the EPR, maybe the brand owner and other investor has to really wake up and think that how best more and more recycling plant to be installed in the country, how best we can have a non-contaminated MLP so that it can easily goes for recycling. And also, as I highlighted about the collection system, the mechanized collection is very much important. I think we have to think about the DRS concept, what the Tomra was talking about, the deposit return scheme. Maybe that becomes an as of today the need of the hour for the country, because without the collection, the recycling cannot go. And very interesting, he said the brand owner should not worry. Whatever the MLP they are using, the same MLP can be recycled and make use out of it for their own consumption. I think that's a very eye-opening, and ultimately I find it is really a sustainable business solution. And in short, we can say MLP is not really waste. We should not think as a waste material. Rather, we said in the resource material, and how best we can utilize the resource in a very effective manner and for make a very sustainable business solution. Thank you so much, Mr. Pillai. For
One
making a
concluding
nice
remark, Professor Saha, if you allow me,
Yeah.
that Noida is not very far. So if somebody is by chance coming to Delhi side, you are most welcome. The plant runs 7/24. So you give us a half an hour notice, and you are most welcome to see the actual lines operating. So in the daytime we run PCR because that's the only quantity available, and then in the night we run PIR. So everybody is welcome to have a look at it. Thank you so much, Professor.
Very good for your gesture for invitation. Many participants may contact to Mr. Pillai to you flags. Moving ahead, we have the next session, which is also a technical presentation. We have with us Mr. Sachin Ganga. He is the sales and marketing head of Evh Kurare Corporation from Japan. Mr. Sachin is a graduate from University of Pune from Polymer Engineering, and then he did a master's from University of Mumbai. He worked with Reliance and NoSil, and finally he landed up to Kurare. Over the last 23 years, he's with Kurare. He's trying to promote another polymer called EVOH, which is a very much, we all of us know the EVOH is a very good polymer for a barrier properties and mainly the oxygen barrier. And he's trying to say that when you really do the recycling of MLP, how really the with the EVH combination, how the recycling becomes very easy and what are the innovative solutions. So with this background, I would now request Sachin Ganga to take the presentation for another 20 minutes to talk on the subject, innovative solution to recycle the MLP with EVH. Over to Sachin.
Thank you, Dr. Shah. Thank you very much. Am I audible?
Yeah, you're audible.
Yeah. Thank you, Dr. Shah. Once again, thank you to FIPS, and special thanks to Mr. Banerjee for giving me this opportunity to talk about EVH. I think I have only 20 minutes, so why don't I straight away get into the presentation? Can I have the slides, please?
Yeah.
We have started in a very interesting flow in the technical session. We have moved from the brand owner Nestle to converter Uflex and to the raw material. Interesting. Generally, it's the other way around, but maybe that makes my job easier. Thank you for that. Thank you for that nice arrangement, Dr. Shah.
No, this will makes you more easy that you know what to talk, what not to talk.
Yes.
If you start with the raw material, if you go on an downward direction, then many times it happens the raw material fellow, he only talks my product is good. But here it becomes more challenge for you. Knowing the problem, the converter, knowing the problem about the brand owner, you have to really help to them.
Interesting. So can I have the presentation, please?
Yeah.
So as the topic mentions, I'm going to talk about EVH, which is our brand name for EVOH. It says Kurare's latest barrier technology. The technology is not new as such. Next year would be a landmark year for us. We produced EVOH in Japan in 1972. So we'll be completing 50 years of EVOH production. But yes, suddenly now EVOH or EVH has got a lot of prominence because of everyone talking about circular economy and sustainability and recycling and single polymer. And in course of next 20 minutes, I hope to highlight certain areas about EVH where we are contributing in our small way to this, to the environment, to reducing the plastics and circular economy, and also assisting recycling. Can I have the next slide, please? So what exactly is EVH? I'm sure all of you know it's our brand name for EVOH, which is nothing but a random copolymer of ethylene and vinyl alcohol. Why do we need to use the two polymers? Because we need to process the polymer on conventional processing machine and also to get the desired barrier properties. If you look at the barrier comparison amongst all available commercial plastics, EVOH has got the highest or the best oxygen barrier as compared to other conventional barrier materials like polyester or nylon or other polyolefins. Next slide, please. So everyone knows about what are the factors in food deterioration, and most important is to keep the oxygen away. That's what EVOH does, where it keeps away the oxygen and controls the biological factors, the chemical factors, the physical factors, where you also require the flavor or the aroma barrier. Next slide, please. So in a nutshell, what does EVH do? I mean, EVH has got so many properties The biggest property of eval is the oxygen barrier. It can be processed in conventional machines. It has got oil and fat resistance, chemical resistance, which comes into play when we are using EVH for making agrochemical bottles. One big application in India, which has caught up in the last 4 years, is EVH plastic tanks are now used in place of metal tanks in most automobiles. When you compare with metallized structures, it has got an excellent flex crack resistance because we are talking of an all plastic structure based on EVH. Next slide, please. So this is just a simple presentation or an explanation what happens when you use, let's say, 100 microns for simple LDP film and a multi-layer structure, which is by just incorporating 5 microns of EVOH in a multi-layer structure, you can see the drastic difference in the OTR, which is obtained from more than 1,000 to almost 1, which is a big achievement for any plastic raw material. Next slide, please. So quickly, we are producing EVOH. As I said, we started in 1972 with our first plant in Tokyo. We produced about 10,000 tons in Tokyo. After that, we moved to Houston, Texas, and the last plant came up in Antwerp in 1999. So totally, we produced more than about 100,000 tons capacity of EVOH, and very soon, maybe the COVID delayed our plans, but very soon in the next 4 to 5 years, we are likely to have our 4th plant somewhere in Singapore. And I'm based out of Pune, where I'm responsible, as Dr. Shah introduced me, for sales and technical service for EVOH. Next slide, please. We have several EVOH grades, which we classify on the basis of ethylene content. Thumb rule is lower the ethylene content, better the barrier, but we also have to think of processability. So certain grades are suitable for certain applications, like at the top of the slide, if you look at the G grade, which is 48% ethylene content grade, we recommend that for BOPP applications. Next slide, please. As I said earlier, it can be processed on almost all conventional processing machines, blown film, cast film, thermoforming, BOPP, double bubble, triple bubble. Now everyone, the new technology, we're talking of machine direction orientation. So EVH extrusion coating is another application. So EVH, when I talk to my converters or my customers, I say that forget your processing EVH, assume you're processing your polyethylenes or polypropylenes. You don't require any special screw. You don't require any special equipment. EVH can be easily processed on your conventional polyolefin processing machines on most processes. Next slide, please. So again, to what EVH does is, as you know, in typical multi-layer structure, the barrier structure is just 5 to 10% of the total structure. So it provides the barrier, and it also contributes in its way to the environmental impact of food packaging. Next slide, please. Again, briefly, which I'm just mentioning, whatever the advantages you get of eval for a circular economy, can it be downgauged? Yes. It has been used in monorail material. Is it an aluminum replacement? Yes. I think someone mentioned about the pharmaceutical packaging. EVH is already being used as a replacement for PVDC. Next slide, please. So Mr. Pillai would definitely agree with me, and I'm sure he has recycled multi-layer polyolefin films with EVH. So it is well positioned in current polyolefin recycling, and it meets all the guidelines which are subscribed in Europe. So presence of EVH does not interrupt the sorting processes as detected in polyethylene films. Mr. Pillai would be better equipped to tell us whether it actually happens. But as far as we understand, EVH is easily recycled in most in recycling streams. Next slide, please. We have several EVH grades based on the ethylene content, where we have the lower ethylene content grades, which can be used to meet the new stringent regulations, where the barrier layer thickness has to be less than 5% of the total layer thickness. We have medium ethylene contents, where again, you require high barrier, probably at high relative humidity. Generally, they are used in combination with not exactly recycling issue, but in combination with nylon, mainly for meat packaging, you have high ethylene content grades, which are used, as I said, in BOPP structures to give a robust structure and which can be easily metallized and coated. Next slide, please. So to once again repeat what I said in the earlier slide, can EVH be downgraded, or I'm sorry, can be downgauged? Yes, of course. You can see for yourself that from a classical 32% in ethylene structure, what we generally use for blown film applications, you can go down to 1/3 of the thickness, from 6 microns to about 2 microns, and you get the barrier is not sacrificed. So EVH can be easily downgauged in multi-layer structures. The new generation machines, the WNHs and the Rifen houses, are well equipped to handle a multi-layer structure, which is, let's say, 100 microns and only having 3 or 4 microns of EVH. Next slide, please. Some applications, what we are working on is an edible oil packaging where nylon can be replaced. Yes, the mechanical properties of nylon could be taken care of by the new generation polyolefins, the metallocene polyolefins, and the EVH can, of course, contribute to the barrier. If I understand, currently used structure for edible oil packaging is, I believe it's 110 micron film with about 18 to 20 microns of nylon. Now that job can be easily done by 1 micron of EVH. Yes, on some machines it's a challenge to produce 1 micron of EVH in a 100 micron structure, but when you're talking about recycling and sustainability, maybe in future you will have edible oil pouches which are based on EVH and which have replaced nylon. Next slide, please. Maybe a structure not relevant to India because we are talking of meat packing, but just as an example, again, nylon or a polyamide-free structure where we have a new generation of EVAL, the lowest ethylene content, 27% ethylene content, to get the mechanical properties. Again, the mechanical properties we assume would be met by the functional polyolefins, the metallocene polyolefins, the thermoformability, and the barrier performance. Next slide, please. I would quickly highlight one application which is growing by leaps and bounds in India, where we have used EVH in BOPP applications. So this last couple of slides talk about EVH and BOPP application. Next slide, please. I won't elaborate on how a BOPP is produced. So this is just a schematic representation of a BOPP process where our EVAL G156B grade, which is 48% ethylene content grade, is being used for BOPP application. Next slide, please. Now, this is where we are talking of sustainability, usage of less amount of plastic. A classical structure, which is a 3-ply structure, which is based on polyester, metallized polyester, and a polyethylene, can be easily replaced by a 2-ply structure where you can laminate a BOPP or a PET. If you're talking of course, sustainability and recycling, a BOPP laminated to a barrier BOPP. The biggest advantage of EVH is EVH being a polar material is good for metallization. Doesn't happen so with your CPP or BOPP, where the surface tension falls down after a couple of months. What we are talking here, not only the shelf life of the packed product, but also the shelf life of the packaging material. Even after months and months, if the dyne value is in excess of 40, even after a year, for an EVH metallized BOPP film, the surface tension or the dyne value remains the same, which is a big advantage when you're talking of when converters or the BOPP manufacturers from India are exporting their film and which are looking at higher transit time. So this is one of the biggest application of advantage of EVH. When you put EVH on surface and you have to metallize it, my converters tell me that they don't even have to corona treat it as they do for other polymers, because it being a polar material, it easily accepts the metal on its surface. Next slide, please. So again, enumerating the advantages what you have of EVOH outer layer combined with metallization. You have good metallization. You have, as I said, eval is easily acceptable to metallization. So these are the big advantages of using a metallized EVOH film in a multi-layer structure. Next slide, please. So in nutshell, I would like to highlight eval or EVOH in combination with polyolefins does not disturb the recycling stream. It has been processed on most conventional processing equipments, and also now new technologies of double bubble and triple bubble and machine direction orientation. You can easily achieve ultra high barrier with EVOH by using our new generation low ethylene content grades. It is definitely the best solution for food packaging. So it's your partner for cost-effective, easy to recycle and high barrier packaging solutions. Next slide, please. Thank you very much. Thank you for your attention.
Thank you.
Wow.
Thank you, Mr. Sanjay. I think
Sachin.
you have given the answer to the brand owner. Our brand owner, Nestle, is using a lot of Maggi and noodles. And what I am told by Burun that the polyester poly, they have a switch over to BOPP because they are also trying to have a down gauging, as well as they are also trying to make the alternative material with a lesser thickness.
I did not mention that because I wasn't sure whether I'm allowed to mention that. So I did not mention any specific brand.
I know that.
So I leave it to Nestle.
Yeah, I wanted to mention it because you say you have come after the brand owner, but I think you have given the answer to the audience that how really the EVOH is so much useful. We all know that. But I think best part, what I understand from this presentation, one of the edible, what do we say, that the oil film, which is mostly the 5-layer co-extruded material, mostly the nylon based, and you said that 70% nylon, which can go by the 1% or 1 micron of EVOH. It's very difficult, of course, to make it on the machinability and all. But nevertheless, maybe this is the food for thought. The oil film manufacturer can think of it, how best the eval can be made. So more and more down gauging, as you said, from 6 micron, you can go to 2.6 micron. That much down gauging, it becomes very minimal and it's very easy for the recycling also. And I'm sure the recycler will not face the problem. What our Deepak Mehta is a recycling machinery man, or our the Jibraj Pillai was doing. But overall, I feel this was an excellent presentation, given a very much eye-opening how really EVOH, all of us we know that, but how really EVOH is so much applicable, especially for the flexible packaging, and what exactly it is required for a MLP, because everyone is thinking about the engineered the material, how we can make the 3-layer to 2-layer, and now people are talking about mono-layer, and there we need more and more coating material, and to improve the barrier property, to improve the functionality without sacrificing its all the important properties. Thank you so much, Sanjay Ganga, for making a nice presentation on a very technical topic. Thank you so much, and give a round of applause. So we move ahead. I'll request, because there are so many questions are coming on the chat box, and I'm sure, Sanjay, you may get some questions. So you can keep on, because I'll read out all the questions once the presentations are over. And many more questions comes on chat box, like question was to Jibraj Pillai, and everyone is trying to reply on the chat box itself. So we are going to our next presentation on post-consumer MLP recycling in a circular economy. And we have with us Mr. Bhomit Agarwal, who is a managing partner from a company called Nature Preserve. And Mr. Bhomit he has started this business on a waste plastic material. It's very recently, only in 2018. And after doing his graduation in commerce from Mijibai College, he's a Mumbaikar from Mumbai. He was in London to do his post-graduation master's in a business school in London. And there he was so much inspired about the comment was given by our Honorable Prime Minister, Shri Narendra Modi ji, about the Swachh Bharat Abhiyan. And that has really triggered him. And he thought, after my academic session is over, and I'll do something for the country so that I can give back to the society. And that has really inspired him how best he can start packaging waste management kind of organization. And with that view, he had just started. and this company very recently, and how he is going to really use the waste plastic material, recreate the material and make it really a value-added product. So this we have to really hear from Mr. Bhomit, what is going to talk about post consumer MLP recycling to make it circular economy. Over to Bhomit.
Thank you, Mr. Saab.
Yes.
Can I just share the screen once?
Yeah. Priya, you can give, yeah.
I think the presentation must be visible.
Yes.
Yes,
You
right?
can make full slide. Yeah, correct.
It's fine, right?
Yeah.
Yes.
Okay, so good evening, everyone. I just wanted to start with that I have chosen this slides or this picture for a reason, that the deck which we can see is made out of wood currently, but we can make the same deck with the recycled plastic. You know, it might be MLP or it might be any kind of recycled plastic. So that is why we chose as this starting, presentation or slide to start with. So moving forward. So, our scientists have spent, years developing and mastering the chemistry of plastic, and spend large amount of wealth and time and other resources to develop the uses of plastic for the convenience of, us humans. So that, the companies and so that we have the better shelf life for, better shelf life for perishable products, hygienic packaging, and, lighter packaging, and many more such uses that provides convenience to us in our day-to-day life. Our biggest example would be during this pandemic, when, it might be in the form of PPE kits or mask, or even simple packaging of foods or other essentials, and providing it to the needful people. As I mentioned earlier, we have spent great amount of human resource and resources to develop plastics and its uses, but we halted somewhere or stopped somewhere after that, which we should not have done, and we should have started at the same time. We should have put more resources in recycling at the same time. So so that we have a complete what we call circular economy. We stopped at that time. So to complete, but it's never too late to start somewhere. And in last 1 decade, we have realized the issues of plastic, of littering and everything, and we have started addressing to it. And people now have again started investing resources to develop recycling, or the whole concept of recycling. And it may be your collection, it may be your grinding or PCR, everything. So we have just started again towards working towards it. So, to complete the circular economy. Let's go to the next one. As we all know that plastic can survive, multi-generations in the environment without degradation. So rather, why not we use that as a strength and not a problem? So it's like today we can recycle those plastic for a material or products where we can use the advantage of not being degraded, and making products where like for example into boards or sheets where it can be used in human settlement, construction material, or what we can say is the secondary packaging of products and bulk shipping, peripherals, and etc. So there's that. And so waste plastic can be, the issue like we have heard earlier that plastic itself is not a problem. It is that post use, it is being, littered around, or it's not being collected in the correct way. So that is where we face the problem. Like Mr. Sir from UFlex just mentioned that, collection of or getting MLP for recycling is a big task. So like even when we started doing our R&D and everything, or try to, do something, when we started, we went to collect post-consumer waste, we could not get it easily in specifically to MLP. Again, like when he said it, because of its, collection issues. So we at NPP are, trying to contribute and be a small part of a revolution, which I would say is plastic recycling. And, so recycling of single polymer is quite, it's very easy. But when you talk about multi-layer plastic, where, there are different polymers in, it might be different polymers together or polymers with aluminum as a barrier, it gets tricky to recycle them. So it might be tricky, but it's not, it's not that it cannot be done. So we are just trying. Then we started our first project called as Project Liberty, where we started the liberalization of aluminum and plastic. And then we moved on to the second project, which is Nature Plast, where we make products out of it. And the products is basically your sheets and boards, where it can be used in multi-purpose, for multi-purpose projects. Like, for example, it can be replaced or, replaced for your plywoods or plastic sheets or what do you call it? Particle boards, etc. So, these things can be where we can use less of wood, or we can have a better life of this. So I think I have a very short presentation. So I think if anything, we can take forward from here.
Yeah, thank you, Bhumit. I think you have given a little idea about how really the waste material can be used as a construction or a building material. And your first picture was really beautiful when you make a platform made of wood and over the water, and you see you need to have a waterproof material. And when
Correct.
you have a plastic based recycled board, and that is definitely is a waterproof and also got a high rigidity and flexible endurance, so that you get as an alternative material. That is one way. The other way, the same material, you can use it, and how best you can make as a value-added product from the waste.
Correct.
I think it's a great journey for you. And over a period of time, I believe the Nature Plast will become very popular in the country, and more. I think the plywood, what we have based on wood, that will be
Correct.
slowly replaced by your Nature Plast. Let's see in the future how really your products will be more visible in the market. Thank you so much, Mr. Bhumit, for making a good presentation on the subject. Thank you. So you move on this subject on the value-added product. As we started that MLP is not a really waste, it's a resource. And having said that, on the same theme, we have with us Mr. Jignesh Shah, who is the managing director of a Deluxe Recycling India Limited. It's a very, very popular company in this field of eco-friendly waste management. Mr. Jignesh Shah is the managing director, and he started his journey in 1999. Stepped into his family business, who are on the paper and board manufacturing, waste management solution, and dealing with the packaging plant as Tetra Pak and the Hindustan Packaging and added recycling portfolio. And he just expanded this business, how best the Tetra Pak material, which is also an MLP, which is a multi-layer material, rather more complicated with a combination of paper, aluminum foil, and plastic. And also when we talk about MLP, the flexible MLP, which is predominantly the polyester, metallized polyester, and polyethylene. So he thought that that's the good idea, that how best his family business can be further extrapolated. Started his company in the name of Deluxe Recycling India Private Limited with a capacity of just 600 tons per annum. And today he is able to recycle about 15,000 tons per annum under his Evh guidance. He has a modest 7,000 square foot of the factory areas at Palghar, whereas he has reputable about 200,000 square feet, and still he feels that much to do. His vision is that how best with his customized technology and know-how, and recently he has also got a patent on his own technology, which is very customized technology. And he feels his future plan, that DRPL, is to reach to the production output of 30,000 plus tons per annum in the next 3 years. And we believe that he will be able to do it with his other leadership and other the dream and vision. With his a lot of vision in his eyes about the subject, Mr. Jignesha is going to talk for another 20 minutes on the subject, value addition to the recycled MLP. What is the success story? Let's listen from Mr. Jignesha. Over to you.
Thank you, Dr. Saab, for, am I audible, guys?
Yeah, audible. Yeah.
Okay. Thank you, Dr. Saab, for the kind introduction. And I would just like to straight go to the presentation so that I can share some information on our products and services. Yeah, is the screen visible?
Yeah, you can make full screen. Yeah.
Yeah, I will.
Yeah, please go ahead.
Yeah, so today I'm going to talk on the recyclability of MLP plastics in its mixed format, and how we can recycle these plastics and create some useful, long-lasting and economical products which are already accepted in the market and which have a very large, consumption story in the coming future. So I would start with the next slide. So we introduce ourselves as the first company in India to be able to recycle, multi-layer composite cartons such as Tetra Pak, basically aseptic cartons. And in 1999, we started our operations with a modest small capacity of about 600 tons per annum. We created two brand of the products, which are basically composite recycled sheets. And these are being marketed under two brand names, these EcoLink and EcoShakti. Our plant is located at Palghar, and we've been recycling, recently we've been recycling, apart from Tetra Pak, multi-layer plastic flexible films in its mixed format since the year 2015. So as I said, earlier we started with a modest operation capacity of about 2 tons per day back in 1998, and today we have a capability to process about 50 tons of mixed plastic waste as well as Tetra Pak waste per day. This is a customized technology adopted from the composition molding process, but modified as per the requirement of our end product processes. This technical know-how is developed fully in India and also patented by the government of India. As another vertical, we also give out this technology to various different countries, and we have almost 7 lines now operational across the globe in countries like Kenya, Philippines, Malaysia, and this. I'm very happy to share that there's a first line which is going to be delivered to Turkey, which will be the first line going to Europe this year. So why recycle? So our natural resources are already depleting, and we have already another concern about generation of waste above these depleting resources. So a step further from optimum utilization of resources is also recycling of this scrap generated from these resources, and ideally to replace these natural resources by creating products which can replace these natural resources with the recycled products. So in our process, which is again developed in-house, we are able to use lots of different kinds of waste streams, mixed plastic waste, which can contain LDP, HDP, PP, or any kind of polyolefins, multi-layer films, which will have at least 60 to 70% P or PP content. We can have a combination of paper, aluminium, or any combination thereof laminated to polyethylene. We can use post-consumer multi-layer films or cartons in a mixed format, and also post-consumer and pre-consumer laminated squeezable tubes. So process is fairly simple that is. So it's basically we are doing size reduction, which is shredding and grinding, and then we are mixing and drying the grinded portion, and then it is going for hot pressing, cold pressing, and then for the final sizing. It's again customized compression molding process. The best part of this process is there is zero water effluent throughout the process. There is no waste that gets outthrown throughout the process. So whatever is generated in the process will get again recycled back into its same format within the process. And there's zero gas emission during this process. We don't use any additives, no compatibilizers, no bonding agents throughout the process. We don't use any glues or any toxic chemicals throughout the process. End product is itself, it's 100% recycled composite chipboard and is itself again recyclable in the same process. In most applications, our products replace wood and wood-based panels, and thereby it saves felling of trees, saves our precious natural resources. This is just to display what our process in a nutshell. So there's a raw material that comes in, it is dispersed, it's milled, which is grinded into small particles. It's formed on a plate. The plate is then sent to a heating press, then a cooling press, and then it is cut, edge trimmed to create finished boards. There's a small animation video to explain exactly what we do, what kind of products and services we do. I will just like to share this.
No sound, Jignesh. You have to start it again.
Okay, just a moment, sir.
Do you ever wonder what happens to generate? Even if you are a responsible citizen, what happens to rubbish after you have carefully disposed it of? We have been thinking about these things too. Sadly, we couldn't find any satisfactory answers. So, we have decided to do our bit for the environment. We start by cleaning our surroundings. The street collectors carefully hunt down garbage and then segregate recyclable material. The materials use material agents who further segregated according to their recyclability. Since we accept all kinds of soft mixed plastic, they send us carry bags, multi-layer plastics, packaging plastics, and others. After this careful sorting, these plastic products finally reach our factory. Our aim is to make useful products from this waste. We start by shredding mixed plastic into fine particles. This is then mixed thoroughly and grind. Using a conveyor belt, we transfer this material to the preparation table and it is spread evenly on flat sheets. After undergoing few more steps like hot press, cold press and cutting, the material is ready to be used. This is when the actual magic happens. The waste is transformed to an alternative material for wooden products like doors, garden benches, chairs, pallets, and thus we reduce pressure on our precious forest resources. However, we don't just create recycled products, we ensure that our processes also care about the environment. So, if you have been thinking about the environment, you are not alone. We are determined to give back more than we take. Come, join hands with EcoLink India and do that one bit extra for Mother Nature.
I hope the video was visible and audible properly.
Yeah, it was there. Yeah. Go ahead.
Okay, so to talk further about the products, the boards are manufactured from multi-layered flexible packaging wastes, mainly consisting of 2 or 3 layer material, including polyethylene. Sheets are available from 6 mm to 30 millimeter, and the standard size of the sheets are about 8 feet by 4 feet. These boards can be laminated with any colored mica, and it's amenable to fittings of screw and hinges just like any other wood or wood-based panel. It has some very interesting characteristics. It will not rot, crack, or splinter like wood. It's a lot denser than wood. It's very highly durable, stain resistant, graffiti proof. It is also very highly water resistant. It has a good aesthetic value. It's impervious to insects, and it's not affected by exposure to most mild chemical substances. More than anything, it's flame resistant and it is cost effective. So it has a very high compression strength, the boards, and they don't expand under varying climatic conditions. There are no knots, just like wooden boards have wooden planks have a lot of knots. It has very good insulation qualities. It can be sawn, molded, and screwed like any other wood or wood-based panel, and it's itself recyclable in the same process. These are some of the technical properties. I think the key properties that we look at are the water absorption. If you see within 2 hours and 24 hours to soaking in water, it's the absorption is less than 0.24%. These are some tests done on the biological and chemical side. So if you see the fungus and acid resistance, alkaline resistance, benzene, so solvent resistance, salt spray resistant, termite and borer resistant. These are all our boards are tested for these and are they're fine with this kind of tests. So when you compare it with other wood and wood-based panels, our boards have clear advantages, such as it's got better acoustic than other boards. Water resistance is very high. There is a better design creativity possible with this boards. It's very economical. It can be machined just like any other MDF or any other natural wood. It has an attractive surface, so it does not need any additional lamination or a decorative surface on top. It's termite and borer resistance. Sorry. It's stable compared to other boards, and it can be thermoformed by heating, and so we can create different shapes out of these boards. So to start with some of the application of these boards, this is one of the largest application that we do with. So these are the 3-wheeler auto rickshaw seat bases. And if you go out on the street, you will find that almost 85% of the auto rickshaws plying on the road would have a seat base and the backrest, both for the passenger and the driver, made out of our recycled boards. So we supply to almost 85% of the manufacturers of auto rickshaws in India. So this is another big application which we work with, and these are basically recycled pallets which are used mainly for grain storage in government warehouses. Specifically, we have our own BIS standard, which is adapted for these kind of products, and our esteemed customers include government organizations like Food Corporation of India, many state warehousing organizations, many seed corporations throughout India, and this is another very large application that we deal in India. This is a very interesting initiative by Bharat Petroleum Corporation Limited, and they've recently started using our boards in form of these modules, the square modules that you see being laid on the road, and then they are putting this layer. So this is laid before the bitumen layer is laid on the road, and according to their research, this avoids the capillary effect of water, which is the main cause for potholes on the roads. We have already built close to about 4 kilometers of roads so far, both within the BPCL facilities as well as outside, specifically Noida Authority, which did a 1 kilometer road just last year. And we are looking at this as a very big application in future, where we feel that almost every road in India can be laid with these kind of modules, and so not only do we divert our waste to a useful resource, but we also increase the life of these roads and again save very, very precious natural resources. These are some of the smaller products we do, like garden bench, door panels, school benches, chairs. This is a dustbin made out of, again, same board. This is a roof sheet which is made out of 100% MLP waste. Again, this is a very large application which is under development, and hopefully by next year we will be launching this product for mass marketing. Pallets, as I said earlier, this is a very large application. These are also used for export packaging for many of the engineering goods, and these are used as more of a skim layer for the external, for the secondary packaging, for the external layer of the secondary packaging. There are some of the gift articles that we deal with, again made out of all 100% recycled boards. Thank you everyone for the opportunity, and I hope to receive queries if you have any, either in the chat box or to our email ID as mentioned on the screen. Thanks so much. Firstly, let me thank FIPS for giving this opportunity to showcase our products and services, and we hope to have more such opportunities in future. Thank you so much. Thanks everyone.
Thank you, Jignesh. I think it was a very nice presentation, but the more interesting few key points what you have highlighted. This is a compression molding process. I think most of the plastic processor knows, but yours is a very customized compression molding process, and where you have done your own technical know-how in terms of the mixing ratio, the pressure, temperature, all have been very much customized. And the second part, what we have highlighted about that this is a patented technology, and that's a really nice that someone has got even on a recycled material, you got a patent, and that's really is very nice to note that. The other part, what we find in the process, you have mentioned that is a zero water. So people have a problem about the industrial effluent problem, the pollution control board, you need some kind of approval and all, and I think this is a company where you have a zero water utilization, is a zero waste, because whatever the waste, it goes back. And that's another interesting part. And you also say an alternative plywood, and you have shown some of your test report which say that it is superior or maybe at par with plywood. And then lastly, what is really an eye-opening for all of us, saying that what are the various applications, start from the three-wheeler, and you have shown the road lane below the bitumen layer. I think that's another thing. How do you stop to the potholes problem? And that is very much required in our Mumbai city. And I think over the period of time, people will realize about the technology, and people will realize about the utilization of this material. And that's the way more and more MLP could be recycled, and we can reach to our mission that MLP is not a waste, it's really a resource. Thank you so much, Jignesh, for a nice presentation. Give a gift round of applause. Ladies and gentlemen, we have reached to the last presentation, which is on a challenges of recycling of MLP. We have with us a very expert stalwart, Mr. Deepak Mehta, who is a managing director of Libom, and more importantly, he is a thought leader of sustainability of our Foundation for Innovative Packaging and Sustainability. Mr. Mehta, by qualification, a mechanical engineer from Bombay University, and started his career with his family business, manufacturing and marketing of engineering capital goods, About 20 years experience, he started Libom Incorporated in 2001, stepping in the field of foreign agency representation business, specializing in solid waste management, more especially recycling and reclaiming technology, and plastic, textile, MSW, e-waste, metal, having tie-up with 11 world-class European companies. He believes that effective and efficient waste management is the need of the hour of the country. We know, sir, about your expertise, your machinery, your technology, your knowledge, and with all this, I think you are with us as an FIPS, and we are expecting what exactly you want to say about the challenges in recycling and MLP, and what exactly the FIPS is also working on the same manner. With this introduction, I request Mr. Deepak Mehta to take the session for another 20 minutes. Over to Mehta.
Thank you, Dr. Saha. Let me share the screen.
Full screen, yeah.
Yeah.
Correct, go ahead.
Just a minute, let me adjust the toolbars. Now it's fine. Yeah, thank you once again. Challenges in recycling multi-layer packaging. I would say a step towards Clean India drive and circular economy, because that is what is being talked about, and that is the need of the hour as well. Just a minute. I'll have to. Just a minute, sir. There is a toolbar that is obstructing.
It's okay now, we can see.
Yeah, no. The toolbar was obstructing my pause button. Just a minute. Yeah, no, something is wrong. I'm not able to enter. The moment I take it, I'm not able to get in. Yeah, it's fine now. I'm sorry for the interruption.
Yeah.
First of all, warm welcome to the world of recycling, one and all. I must first thank Mr. Pillai for making my job a little easier. Right direction. The hot topic in the flexible packaging waste management, MLP recycling. I mean, I would be dwelling on two aspects: industrial waste stream as well as post-consumer waste stream, because both are equally important. The industrial waste stream, the types and kinds of various monolayer as well as multi-layer as well as plain or unprinted packaging waste, which could be even multi-layer, as well as heavily printed multi-layer packaging film waste, metallized as well, but mainly coming from the printers and the converters. And this is the post-consumer waste stream. You can see for yourself, it is comprising of many types and kinds of flexible packaging waste emerging from different resources. And the most challenging one, as I see, is the multi-layer packaging waste. As you can see from the photographs, it is not only commingled in nature, but it has all types and kinds of contaminations as well. But as I believe, challenges evolve solutions. What are the challenges? Let's have a glance at it. First and foremost, varieties of flexible packaging, monolayer, multi-layer, same polymer family, multi-layer, different polymer families, vacuum metallized, aluminum polylaminates, paper polylaminates, paper polyaluminum laminates, so on and so forth. Types of packaging, plain, mildly printed, heavily printed. Contaminations within the packaging. Apart from additives, ink and glue, you have the presence of undesired polymers, paper, wood, metals, glass, stones, stand, leftover organic waste, original fill within and on surface, and most importantly, the typical odor or foul smell, as Pillaji rightly said, emerging from the food waste. What are the available options? If you see the pyramid, of course, first and foremost is prevent, reduce, or reuse, but that it's easy said than done. It's a tall task in itself. Among all the options, mechanical recycling is the first recycling option, being the most cost and energy efficient solution. It keeps the raw material in the loop itself. And then chemical recycling is the next best option. Chemical recycling is not competing, it is rather contributing to mechanical recycling. Proof of ecological feasibility is in progress and is life cycle analysis, and positive versus incineration and fossil-based virgin plastics needs to be seen. Economical success of chemical recycling will need a strong policy support. And of course, added to that, even in chemical recycling, existing technologies like sorting, washing, input stream, definition, extrusion is still going to be the key pillars. As we see in chemical recycling, from the crude oil, the polymer is made through the chain, and at the end, plastic waste gets generated. So what are the options? Very first is reuse the in-house waste or industrial waste back into the product, or undergo mechanical recycling and go into the loop, or solvent-based recycling, dissolution process, and go into the loop, chemical depolymerization or solvolysis, again back into the loop, thermal conversion, pyrolysis or gasification, going into the loop. But as we go towards the left-hand side, in terms of the technology, the capex, energy demand, and complexity is equally far more challenging and far more worth recognizing. Thermal conversion, pyrolysis. Pyrolysis requires a well-defined input stream, mainly polyolefins, preferred shape, thin film as fast as possible. What are the unwanted materials in general? PVC, PET, PA. Now, this definitely cause concern when we talk about pyrolysis. And of course, the inert materials, which is existing in post-consumer waste stream. What are the key challenges? It is low in weight. Upscaling is a challenge. Purification is a question. And if you see the process of pyrolysis, basically 10 to 20% is the gas fraction, 70-80% is the recovery fraction, and 2 to 13% is still the solid fraction. And this is where basically yield becomes a big question mark. This has been supported by a study conducted by BSF. So in a nutshell, pyrolysis again is going to be a challenging area when we come to multi-layer packaging. The plastic problem is yet to start. If you see the world consumption, it's estimated to 460 million tons by 2030, and today it is 360 million tons. But if you see the graph, overall, mechanical recycling is going to have its own weightage. It is going to have its own utilization as compared to the alternative technologies. As compared to the chemical recycling, looking at to the pros and cons, definitely, at least for the next decade, it's going to be the mechanical recycling in India, which is going to be the key driver for waste management. What are the spatial highlights on mechanical recycling when it comes to MLP? Multi-layered, laminated, or metallized packaging waste has so far been either very difficult or at times even impossible to reprocess, viewing the complex structure. Recycled granules or pellets produced on conventional recycling plants are typically inadequately either homogenized or degassed or melted, and this makes the reuse all the same difficult or challenging. State-of-the-art technologies are tailored solution for production of completely homogenized, degassed, filtered recycled pallets. And the features like de-inking, deodorizing, dosing systems can add value for the end users. Let's have a look on the mechanical recycling, since this is the technology I want to talk about. Unique solution: a large cutter compactor extruder combination with melt filter before degassing. Let me repeat, melt filter before degassing for optimum filtration and highest degassing effect. When we talk about waste, or when we talk PCR waste, preparation of the waste is very important prior to extrusion. And this is where in a large cylindrical drum that you see, we undertake multiple operations and prepare the right type and kind of waste before it is extruded. And then is basically, the extrusion process, the melt filter before the degassing, and the degassing zone itself. And then is the downstream pelletizing system. As I said, when we have multi-layer packaging films, which has multiple structures, heavy prints, it has residues left over. If we talk about the PCR waste, degassing plays a very, very important role. In a technology where I'm talking about, basically, we are talking about triple degassing. At the plating unit, second, reverse extruder degassing, and third, double venting, high performance degassing, high vacuum degassing. And unless the gases get removed, the resultant granules will not be bubble free or will not be free from any of the off specs. And this picture shows for itself the comparison of degassing efficiency. The picture on the left is with the standard conventional extruder with a degassing capabilities not up to the mark, and you can see the fish eyes or the bubbles in the film. And on the right is with the triple degassing, and you can see the nice surface without the gases or without the bubbles or without the fish eyes. Equally important is the filtration. Post-consumer waste does have a lot of leftover contamination. Despite of best of washing that you undertake, it still has the embedded sand particles or embedded particles within the film structure itself. So effective filtration plays a very important role. Normally for post-consumer waste, the observation reveals that leftover contamination is more than 2%, 3%, going up to 5%. And this is where laser filter plays a very important role in removing the leftover contaminations. In some of the applications for high-end uses, even double filtration is considered, where you have at the upstream a laser filter and at the downstream automatic backflush filter. 70 microns on the laser filter and 30 microns on the backflush filter, ultimately making the end granules far more superior in terms of its quality and its reuse. This is an example of it. You have basically the converted into the granules and then a produced film. These are some of the pictures of recycled granules or pellets made from Indian waste. I would repeat, these are not the pictures from Europe or any other country, but these are the waste sent by our customers for trials, and these are the actual recycled granules. Pillaji had already briefed and showed it, but just to know, typical application for such kind of multi-structured recycled granules is injection molding. Several types and kinds of injection molded articles you can make. Other potential applications are the middle layer of PE or PP pipes, or even complete agricultural pipes, roofing tiles, as Jigneshji explained, paver blocks, partition blocks, barricades, road dividers, speed breakers, tarpaulins, slip sheets, dam courses, pallets, profiles for outdoor furniture application. Strapping is one of the interesting applications, particularly when you have metallized OPAT or metallized OPP films. And the list is just to show you a few end-use examples of the recycled granules. You can see the pictures for yourself. What are the products made out of it? A few more application photos, injection molded articles. The one that is highlighted with the red oval circle is basically showing the straps. And this is made from BOPET and BOPP metallized film. Well, when we talk about post-consumer waste, leftover order, despite of passing through the extruder, is still a concern. So if the leftover order is a concern, and particularly for certain end uses or application, here is the technology which can be considered the deodorizer or the refresher. And you can see high volatiles or orders get removed during the extrusion process, and low volatiles and orders get removed during the refreshing technology, where temperature and time is being considered for removal of foul smell or the odor. Bringing value to recycled granules or pellets. I mean, post-consumer waste has a very typical mix. It is practically of so many types and kinds of packaging films. And this is where one is never certain about the end product, because input is equal to output and properties correspond to the source. So variation is inevitable. Blends of polymers, its ratio is unpredictable. Polyester content could be 5%, polyester content could be 25%, polyamide content could be even 5% or even 15%. So one is never sure what is the ratio. Despite of best washing, contamination could still influence the property. Sometimes the recycled granules are difficult to process in an injection or blow molding machine or even extrusion machine. So what are the tailored solution? As Mr. Pillai said, simplest, add polyolefin, because this is also originating from the waste. So use polyolefins in order to neutralize the effect of polyester or polyamide. You can also use compensators, modifiers, stabilizers, additives. In case for film application, you need to play around with the MFI. You can increase the MFI or reduce the MFI. For applications, you can have optical brighteners, master batches, fillers, so on and so forth. So flexibility is available. Only question is for the end users, what is economically viable? And this is where the recycler needs to really evaluate what can be added in order to recover the cost out of it or ensure viability out of it. Just to give you an idea, what are the dosing systems and how they can be placed. I mean, you can have a powder dosing system, liquid dosing system, or even granule dosing system. And typically, there are points where you can dose. One is straight into the extruder, second is the feeding point. The bottom pictures show you how the location of the dosing systems are and where they are placed. These are the pictures which also show the actual equipment being placed on the extrusion system or recycling equipment. Well, having said that, let me slightly brief about, the pre-treatment of the waste, because this is very, very important. Post-consumer waste does require pre-treatment prior to extrusion or making any products for that matter. And there are a series of equipments that go into sorting, segregation, and separation processes. Just to name a few, these are the listed ones. Sorting of flexible packaging. It is difficult, but possible. And this is where basically I would like to give you a little overview that what has been done and what we have done. I mean, it's a well-established application for Tomra company. It is already being done worldwide for MRF, material recovery facility, and there are many plants in Europe and now also in India. We already have a working plant in India for the MRF, which covers the MLPs. And there is an increasing demand for dedicated film sorting facilities of late. This is basically, a typical sorting machine. The sorting technology is designed to remove contaminations present in the packaging, NIR, for sorting by polymer grade or even paper, VIS, the spectrometer for detection of color, deep laser for non-detectables by NIR, for example, the black objectives, stones, glass, and you have the metal sensor for detecting metallic objects. And this also includes flexible packaging with aluminum packaging. So you can also remove the flexible packaging with aluminum in it. This is the typical flow process for the flexible packaging recycling. First is, the pre-processing or preparation of the waste prior to optical sorting. Then the shredding, because an optical sort has size limitation. It can handle from 50 millimeter to 250 millimeter, maximum going up to 300 millimeter. And then is the optical sorting machine. It could be one or it could be multiple, depending upon the type and kind of targets and the input composition. Followed by sorting is the washing and the extrusion process. Sorting of multi-layer packaging, again, just to give you a little highlight. Tomra sorters to remove all the multi-layer packaging or other contaminations, and Tomra sorter only to recover PP film. As far as the entire configuration is concerned, it can be oriented based on the customer's need and customer's desire to recover as good and recover as reject. This is basically, auto sort speed air, because along with time, we are talking about volumes. And when we talk about volumes, definitely we need a technology which can handle 1 ton per hour, 2 tons per hour, 3 tons per hour. And this is where basically it's the auto sort speed air. And for India, I would say it's a little time. We are little for this technology, but at the moment we definitely have auto sort, which is good enough for the present need and demand. How does it really operate? Basically air is the medium which is being used to keep the flexible packaging film in a very stabilized position close to the belt, which is not possible with auto sort, because when we run the flexible packaging film on auto sort at a speed beyond 1.5 meters per second, the film will tend to fly. And this is where ejection becomes very difficult. So as you can see from the bottom graph, Tomra auto sort for 600 kgs per hour for 1 meter width of the sorting, and auto airspeed for 1.2 tons per hour for 1 meter wide sorting width. After the sorting, it's washing, separation, and drying. Mr. Pillai has already covered this subject, so I would not like to go into much details, but just to give you a broad idea, I thought I should bring along this topic in my presentation. This is an overview of a typical wash plant. Let me once again mention what Mr. Pillai said. The entire configuration depends on the input material stream, and having known the input material stream, entire equipment configuration gets laid out: friction washes, hot wash, caustic wash, neutralizing, so on and so forth. This is the tech for the future, the de-inking technology. When we talk about, the sorted waste only of printed structure, surface printing structure, then de-inking definitely is a technology that is worth giving a thought. How does it really work? Basically, you have the printers and the converters producing the films. They are being used by virtue of the end product. They end up as a waste, which goes to the recyclers into granules, and granules get used for further manufacturing of the products, injection molded or blow molded or any other extruded articles. But suppose you have the structure which has only the surface print and it's a monolayer, it makes a lot of sense to remove the inks and get a value addition from the granules. Just to give you an idea, in terms of the process, it's very simple. At the bottom, you can see you have basically a printed film converted into a plain film and the granules made out of it. This picture will give you still further idea. The LDP printed film flakes converted into natural, converted into granules, and from the granules, film is once again produced, the white LDP film. Same way at the bottom, transparent film. This is basically the BOPP label with UV ink, where it is converted into a transparent surface. Same with rigid packaging. This is how typically a plant would look like. At the moment, it's only available up to 500 kilogram per hour, but higher volumes are being under consideration depending on the need and the demand. Thank you very much and happy recycling.
Thank you, Mehtaji. I think your last word was very nice, happy recycling. And this is the way we can promote recycling more and more. Your presentation was very overall idea about what the recycling, starting from mechanical recycling, chemical recycling. And more importantly, you say that the demand, the kind of demand which will have a 460 million ton, which is coming to 2030, and today you got 360 million tons. So there are much opportunities coming in the recycling business. And of course, you have touched about how really do the quality of the inputs material, the raw material, because based on that, one has to really configure about the washing line, and that helps to go to the recycling plant. You also touched upon about the polyolefin base, because single layer material is always good for the recycling, but if they have a mostly polyester or nylon polyamide based, we can always go for a fertilizer and to make it a very friendly recycling manner, which is already established technology. Overall, you have made an overall idea about the recycling of MLP, and not only MLP, including the other plastic waste, how to do it, the sorting, washing, cleaning, recycling, everything has been covered. So nice presentation. It was a very integrated approach to how really do the recycling of the plastic waste. Thank you so much, Mehtaji. I think our time is now 5:50. Now I'll hand over the mic to our moderator, Mr. Deepak Manchanda. Manchanda ji, it's up to you.
I think there are some questions also.
Is there questions? Yeah.
Deepak ji?
Yes, there are some questions, but I think we have got some answer. Burun is no longer with us. No, they were addressed to Burun and to.
No, I think one question was, what was the opinion about the replacing MLP with monofilm with monomaterial based flexibles? Burun has answered. No, this has not been answered. Burun has said, have you done work on ultrasonic sealing? Burun has replied, sir, I need to, oh, no, not that. He said, yes, we are working ultrasonic sealing. It's a good solution to reduce sealing width as well as consistent sealing. The question was how the demetallization is done. Mr. Pillai, have I caught you right? Are you saying that PET and polyolefin can be capitalized and mixed together in the recycling steam? Mr. Pillai has already replied. He said, yes, no need to delaminate or demetallized. Yeah, I think all the questions answered has been given.
And we can say that any other questions which the participants may want to address later,
yeah,
you should address it to us and we will try to get those things clarified.
Yeah, they can address to our FIPS. We can always reply to that. Correct. Yeah.
So thank you, Dr. Saha, and thank you to all our guest speakers for showing us the various possibilities of MLP recycling. We are already over time, and we will now, to sort of round up the session, I'll invite Mr. M.K. Banerjee to give us a recap, a brief recap, concluding remarks of what...
I think to save time, I'll talk a little bit about myself only, and then directly I'll go on that.
All right. All right.
Yeah. Yeah. Thank you, participants.
thanks for showing interest and joining us in this knowledge and learning program. I'll start with our co-organizer, Professor Sabu Thomas, for giving immense support and help to us. And his speech was, by itself, it says that we are far away from per capita consumption of plastics, only 2 kg as compared to world standard of 50 to 125 kgs and all this. And we do need multi-functional polymer based laminate because shelf life and product keeping is very important. With the monomaterial, monolayer, we cannot capture that longer shelf life, aroma, and then freshness. Yes, some product can be done, but not as a whole. So this is very important. Now, Dr. Lakshmi Raghupati, she told us that MLP, it is the need for certain product keeping, longer shelf life, and also some of the hazardous chemical. We cannot use simply polypropylene or HDPE, but we need that, leak-proof, hermetically sealed. So there we need multi-polymer. And the way we design the structures, that is very important. So instead of scientific design, people try to use everything possible under the sun and make a multi-layer structure, which eventually it is very difficult to reprocess and recycle there. So another interesting, she said that, let's not tell that plastic waste. So waste plastic, instead we should talk about, the post-consumer plastic. It could be the source of raw material for recycler. And they have very innovative process, mechanized and technology to differentiate and make very fruitful use out of that. Burun Banerjee from Nestle, he said, they are global company and they think so much. There are so much of scientists are there, technologists are there. They made, global commitment for multi-layer plastic or plastic as such. What kind of plastic they use, renewable plastic or plastic from plant source, so that load on fossil fuel comes down. So they made a golden rule, which is very interesting to learn. You can go to their website and see that. Jibraj Pillaiji from Uflex, he said that they made a customized recycling machine for multi-layer plastic because we don't have clean disposal mechanism or clean collection system. So we have all these extra problems, which generally not there in abroad, US or Europe or even Taiwan. I have seen that. So they dispose very systematically so that you can directly take that without any contamination, cross-contamination or organic contamination or biohazards, and that can be directly reprocessed and reuse that. And it is very kind of him that he said anybody interested to see one of this kind of large wash segregation line, so people are welcome there. Sachin Ganga, I know Sachin for last 30 years, and Kurare, I have visited Kuraseki personally. I mean, they make barrier. EVOH is basically barrier polymer, but it goes well, very friendly manner with the polyethylene. So they have various grade for a specific process or machine categories and all this. Though it is EVOH, so low ethylene, high ethylene content depending on that. And it is good to know that they have a grade now, which I have seen that he has not discussed that much, but picture I have seen that it can replace nylon, which is a difficult to recycle because nylon is a tough material and it takes different temperature profile than polyethylene or polypropylene. So they have a EVOH grade which can be recycled along with the polyethylene or polypropylene. So this is a fantastic proposition they made. So new EVOL grade with 27% ethylene content. So Bhumit Nature, he's a very new and very young boy and all this. I know them. So he tried to make like plastic wood kind of features, which can be used machine, mill. You can make different profile, design and all this. So we wish him all the best. Deluxe, they're already established. They have a patent on the recycle process and product, I believe. So that is fantastic. Jignesh bhai, congratulations to you. And Deepak Mehta ji, as usual, is like, loads of opportunities, loads of processing machineries are there. And according to the need of that particular recycling and the customer, if we can make a business case, he has a technology ready for that. And it is also interesting to learn that though we talk about chemical recycling, but it is okay, but it is also come with its own baggage. That is the contamination and then, the residue part out of pyrolysis techniques and all this. Yield is a question. And then, associate royalty and all these or catalyst, if any. So that also, to be seen. However, he mentioned that mechanical recycling along with peripherals like deodorizing, de-inking, degassing. These are some of the new features by which you can get a very good quality granule. So you can make a granule, reprocessed granule gradation 1 to 10. That means if it is a class 1, and if we can predict the performance of that, quality of that, characterize of that, we get a much better value. And by virtue of adding different kind of process and different the features, which is a modular, we can add very value-added features into the reprocessed granule, which otherwise may not be readily available with the virgin polymer. So this is another good thing I have learned from Deepak ji. Thank you very much for that. So at the end, I must tell our two director, chairman is, he works, I think he works 18 hours in a day and night together. Thank you, sir, for that. And we don't mind, he called me at middle of night also, you are there. And Professor Ghosh, and also nicely he explained our model, kite model and all this. So we want to be the enabler of, the science and technology related to plastic and plastic processing, including recycling and all this. And lastly, all my participants, thanks a million for joining us. And any question, anytime you have, our email address, please shoot that. We are obliged to go back with answer. So take that opportunity, please. Thank you very much.
Yeah.
Thank you. I think with that, we come to the end of this program, and we look forward to all of you joining part 3 of this webinar, which will be in February 2022.
Probably we may go for a physical also, all depends on the situation.
Yes.
Yeah, so that we can get larger participation. But the nice thing, we started at 3 and it is exactly